different kind of data sources. Like whether you feed any text, social media from Twitter or Facebook, let's say from YouTube, whether it's video or anything, right? A news. So you can adapt to that, and then your system should adapt to that, and you don't need to rebuild the system again and again. And for example, when I work as a time series modeling, then I do not know what kind of time series I will get. I may get a stock market, I may get a weather forecast, I may get it deployed in nuclear reactor, which is very sensitive. I may get deployed into hospitals. Are simple basic use cases of, let's say, time estimating that the time to delivery, that is also time. So if anything which is time series, probably my system should able to work on that, and that's what the expected. Because as an industry, if you build a solution, you cannot go and then with the new requirement, you do not go into the re-engineering process and then do all these things. So, 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 so to do that, we need to understand that our algorithms that we use or we build our algorithms our pipelines, that they should adapt to different kind of structure and other things. The next expectation would be self-maintaining systems that can learn continually. Now, for example, let's say you put a 1 year of effort of building a system, and example would be, let's say, social media analytics, and you build a system around news feeds or blogs. And next, now you have a requirement that you you also need to have the data from Twitter. Now, how can your system learn that, okay, these two are different mediums, right? So, for example, one basic difference from the news media and Twitter is that news media is very well structured with, and Twitter is short text. Now, the system needs to learn that, okay, my model maybe need to retrain to adapt to that changes. And similarly, it is also called the self-maintenance, that, okay, if I am getting new data source, how can I change my pipeline and to work with that? Third is very important, is that minimize the human dependency, because once there's multiple things. That's as an industry, when we deliver a product, a machine learning product to the user, we do if we cannot we need sometimes user feedback, but we may not we should not dependent on that, because maybe user is not providing enough inputs, and our user is irritated with that. So that is one aspect, that we should not depend on that. We should, and then we need to figure out ways to that. Similarly, for example, same continue to previous point, I do not want a scientist or engineer to go again and try to solve the problem again and again. Can we have a generic solution for that problem? The fourth problem that we get, obviously, in social media is that, and other parts also, that the information is being generated daily and a huge rate. And then it's also diverse, like sometimes video, text, image, everything, and noisy text also. Like if you go to Twitter, people are using shorthands. Now, how to deal with this unstructured, huge volume of data that's coming daily? And then that's a problem we call as big data, that our system is not capable to deal with that, and then the process in time are other problems. And then whenever you build a system, let's just, be it industry or be in labs or somewhere, and industry labs also, everyone has two things. One is that the cost is regarding, if you buy a CPU, cores, memory, everything, then you need to pay in cost, and also the cost in terms of timing, that how responsive your system. We cannot wait like 1 or 2 hours for certain things, or let's say one day. We cannot wait for that. Then you need to optimize your algorithms and pipelines and the other aspects, keeping that you are giving a good quality output. And the sixth point is mostly we face in the industry, is that, and this is very big challenge for us, that we have to build a system for different users with different customers, but we can see their data. Now we don't know. Now the very first step of a machine learning system is to understand the data, but we don't know that because we cannot look into the data. It's a privacy issues and other things. And then we need to build a system which is efficient enough or resilient to the change in data or reliable enough that even and the same thing the same is that our system with the beat algorithms beat a pipeline level be other things that we should adapt accordingly because we do not have that access. So this is expectations. So for example, I've taken that example, which is a very simple example that this is one thing is that which is called hyperparameter tuning. So hyperparameters, there are two kind of parameters if we can broadly decide, which we need to decide before we start the training of a machine learning model system. Another is that they learn during the process, right? So hyperparameter, and then if you choose proper good hyperparameters, then then this lead to best parameter learned during the training, and then you have good. Now, this hyperparameters also can be of different type, and then can have different range. Now, to find a parameter is a difficult problem in sense if you don't know the data set itself. If you're getting a variety of data sets. So let me convert it to the what if you come to industry or trying to build a system, then how this problem converts to a bigger problem. So what is the need of uh, uh, need of a system, machine learning system industry is that if you're doing hyperparameter tuning, you cannot take whole amount of data, the whole amount of time because you also have to train and then predict, and then you also need to learn continuously. So every time you cannot train and then you cannot tune hyperparameter. So it's the one part of process. For example, one task that I have given to my team and we worked on this is that let's take 100 different kind of data sets, and we cannot look into the data sets. So that's first thing is that data you cannot look into data that you cannot analyze. So now how do we know that which parameters work on what? Second is that let's use the the algorithm which is very computational and intensive. Like so for example, this is XGBoost and then gradient boosting and other neural nets, and set more than 5 parameters, right? And then the data set should be huge. So these are the requirement that your memory budget of this, time budget of this, that your whole training should complete in 1 to 2 hours, and then your quality the result should be expected as quality should be as expected. Now this is a huge problem, and now how to solve these problems it's just not a hyperparameter tuning problem now. It's a problem to how to solve or fix and speed up everything. So first thing would be whether can I, without looking into data, can I get something from that so that I can use that to intelligently decide few things, or let's say, can I improve my algorithms, the hyperparameter tuning algorithms. There are multiple algorithms. Can I improve them? Can I use them? So that they can get and they can like efficiently train huge amount of data. Can we get something like representative data? So this way this problem is not a simple hyperparameter problem, but it breaks down in different problems at different levels. So it breaks down at data set level, it breaks out at engineering level, it breaks out at algorithms level and all, right? So that we need to do. So first thing is that what every industry or any system which will look for is that how to solve this problem of big data. And so let's so these are a few solutions that we think over the period of time we will need if in building any machine learning system or platform, and then we need to work on that. First is that we have an big data technologies which can efficiently store and process the data in a very low cost. Second is that automated machine learning. Automated machine learning is the concept where you automate like machine learning is a step of a process which has multiple steps. Can we automate few things so that we can speed up reduce our time to like do trial and error, or trying to find a few, let's say for example, for a data set, what algorithm works best. So now if you, let's say the problem is regression, and then we know that there are 20 algorithms, which algorithm works best. So that I don't want to spend a time, manual time to on and to do that, right? So this kind of thing, that how can we automate machine learning so that it can decide by itself that what is best. For example, in the social media, let's say you're getting news data and then it's well structured. Now suddenly you putting Twitter feed. Now automated machine learning system should adapt so to say that okay, this is unstructured structured text, this is unstructured text, or short text, this is a noisy text. Now I need to change my algorithms, or tune my parameters again or something. That way. That we need to that kind of things we need to understand. And then we certainly have to have efficient and robust machine learning. That even if you, let's say I have data, and then certain data I develop my model on that. Now if there's error in the data, some other data is coming, can I, if my system is efficient enough, or not efficient, it's robust enough to deal with the errors or the changes that coming up with the new data, right? Efficiency comes in the like how do we optimize our algorithms, or the pipeline, and quickly, like if you train, let's say you have 10, even if you have 10 data sets with millions of rows, and you decide to train a single algorithm on all 10 data sets with the huge 10 millions of rows, then it will not going to work. It's not going to work that way. So now we need to work on every part of it, every step to optimize them. And then obviously the continuous machine learning, which says that we can there could be change in data, or change in something, or new information coming in, and now your system needs to be adapt to that, and then system needs to be continuously learning. So now you need an efficient machine learning algorithm, but you do not need to like learn one time. You may need to learn daily, monthly, weekly, or let's say it depends. So based on usage. So that's why these are the things that we need to work. We keep working on, and then probably I'll go in deeper in the first two, which we can explore, and then probably we can exploit them. So big data is generally, this is the precise term I've taken. I need to put the reference. But yeah. So this says that it's a simply big data is not a huge. It's not related to huge data something. It says that if you cannot process or store, or analyze the data within given commonly used software with the given cost, if you cannot do that, that problem itself converts to big data problem. And then definitely, I guess most people must be familiar with this big data. It's been long here in our for the years, and then the big data, definitely we are generating lot of data. So that's a problem for us as a machine learning system or analytics system. And so I guess briefly I can talk about that. The characteristics of big data is a volume that's generating as a huge volume, and the let's say petabytes, and other velocity data is changing, like so Twitter feed is you're daily getting so many millions of tweets. And then variety, right? We talked about like video, text, image, anything that we can get, short text, and then noisy text and all. And then how to whenever you face a problem to deal with the data, that converts to big data given your resources. And yeah, so that we already talked. Yeah, so challenge of big data would be like data growth, quality of data. The data is noisy, and you need to work on, and then it's a different format, and how to process that data. So these problems has been focused since last many years, and then people have come up with different technologies, I guess, and then they work on them. For example, first, if you have storage, then probably it should have distributed storage, and then you should have a distributed processing, and then there's a concept. Let's say, do you want to learn as your data come, or you want to store and then learn? So that is what is the real time versus batch processing, and these are different technologies that are in the market. and people are using them to solve first phase of the problem, that cost efficient storage and processing. Yeah, and then building the models on top of that. So different players are there in the market, and we they solve the problem. Now, and so what, as a machine learning community, this is a hardware related thing in distributed processing, but as a machine learning community, we have, or we need to also work on certain aspects of it, that because if you have used data, can I have some representative data, right, or something, so that statistically, on the algorithms level, can we optimize our algorithms, and can we improve them. And then can we build let's say, algorithms that can work across data sets, so that you get a single algorithm, a single system which can work across the data set. That would be the challenges that we have to solve, and we are trying to solve that everyone. Yeah. So next comes is that what we talked about is that next part is that how to minimize the redundant or repetitive effort of analyzing the data, and analyzing and building the pipeline. And then also, let's say if there's no human, let's say if the system is working and suddenly there is change, and then you don't have a time to fix that. Let's say, for example, you cannot like fix in next 2 months, because you need to have all re-engineering, then all the analysis you need to do, then probably it go into R&D research, and then we need to find the problem. But by that time, can we do something? And that's the thing that we're trying to solve with automated machine learning. This is a very good quote from this paper, which is published in NEPS 2015, that a machine learning system could be only useful if it goes to broader audience, which who are not from the science background, not from the engineering background, they are non-technical, but they can understand and they can operate with the machine learning. And so this is a typical process that we do while building a machine learning pipeline, is that first we have a data preparation, we get the data, we prepare the data, like it like and then we extract the features from that, which will be fed to the algorithm, and then algorithm, when you select algorithm, then algorithm, then you have to tune that hyperparameters for that algorithm, and then train, and then probably analyze the results. Now, so for example, when we build an automated machine learning system, so that so given a data, we need to first identify, let's say, for example, whether what kind of task that we're trying to solve. For example, whether it's a classification task or regression task. Right? So this way we need to solve. And then the thing is that, for example, since you cannot look into data, then you need to figure out what type of data you get in the columns. Like this category column, containers, or what. And similarly, is there any noise? Can we have a minimum data treatment that we can do? So, yeah, so that is what will be the part of data preparation. And the feature engineering is that, let's say for feature selection, you have 10 features. Now you need to try to find out which features or subset of features works well. And if a human has to do that, then probably they will take a huge iteration and then invest time, which can a machine could do that, like sub-selecting the features from that and trying to find out which features work. And similarly, as I already talked, so there is a regression problem, then you have 20 algorithms. Which algorithm could work well for your that data? That is also, that could be also automated. And then hyperparameter tuning, and then analyzing the results is still we not yet there, but as a community we can work on that also. So the thing is, it's taking the load out, and then so that, and minimizing the redundant effort, so that we can fast track our work, and then probably we can save the time and then focus on our different problems we have to solve. Yeah. So yes, so this I guess I already talked about this. Why do we need auto ML? Okay. So this is what this is again from that paper only, which talks about that. what we need to do. So already I've given that we need to data processing, feature processing, and set the hyperparameters. And but the thing is that the goal of AutoML is never to have like a single solution. It is to help to remove that repetitive task and that we have to do manually. And that is the goal that we have for AutoML. I can take an example. For example, a pipeline. Let's say there's a pipe, and most of the AutoML platform work on this part only. First, let's say there's a data set, and then what we do is that given the data set, let's say 10 or 20 algorithm. Now, I don't want to invest my time to train and tune that for 20 algorithms, right? Because I have a time budget, I have a cost, I have a memory allocated to. If I my machine learning platform is like taking like 1 hour, 2 hours, 6 hours, let's say one day, that is not good enough for me. What we need to do is that, let's say first what we do, I cannot go into detail, it's proprietary, but I can give few things like, for example, let's say 20 algorithms. Now how can you choose top 3 or top 5 algorithms? And even without training, because you cannot train and then on the huge millions of rows and then try to find that algorithm. I mean, now this converts to the problem that how to get that without even training. Right. So one thing that yeah, and then first the problem is that you get the top key algorithms, and now you have huge amount of data. Can I represent uh, a data with a smaller subset for that huge data? So that I do not lose any value, but I have a small amount of data. Also, there's a different problem that I can put into. I have different type of data sets. Can I have a representative data set which can equally represent all these data sets? So that I am reducing that amount of data. And that's what we were trying to do with the adaptive sampling. Third thing is that we already talked is feature selection, hyperparameter tuning. And this is more or less the same architecture every AutoML system follows. And that's what also will solve in the problems. Right now, there's a focus on mostly on regression and classification, mostly with the which have the numerical and all this data. But the thing is, let's say we have social media and then we have NLP, then we also have different type of problems to solve, and like sentiment analysis and other things. So that is still open area, and then if we can invest in that and then try to find ways to build not and because our automation system is not just a pipeline. It's every algorithm, how to decide which algorithm to use, how to extract the characteristics from a data set without looking into it, are how. So all these things, little things involved in that. And then let's say us trying to understand a different kind of task automatically, then we need to feed that way to the system, that how can we decide. Yeah. So these are the things. So I guess these are some automation technologies already in the market, and they're working on it. And some players have also started working on NLP, but still it's not a well good system. But we need to. But yeah, but we should, when we work as a social media text analytics, probably we should also focus on building such kind of system so that we can efficiently deliver things. Yeah. So
Nilesh,
yeah.
sorry to interrupt. It seems there are some distortion in the mic, in your
Okay.
audio. So can you little keep your mic closer to to you?
Okay, sir.
Um,
Okay. Okay. So then this is the last slide. Then there are a lot of technologies and the systems that we can use to like fast track our system building or our research or any engineering part or anything that we can do. And with that, I'll end my session and open for questions. Yeah.
uh, so Nilesh, because of the say large participant, we are disabling the audio questions. Okay, questions are
Okay.
taken through chats. So I will
Mm-hmm.
also monitor, but just some questions from my side. So can you highlight to the participants what are the kind of industry-oriented problems, okay, taken from the social media analytics aspects in the industry-oriented problem you guys are working?
Okay. So, first problem that we try to solve is that, let's say, mostly we also work on the Twitter analytics. So the first problem is that the thing is, the noisy text is definitely a problem that everybody is using short text and then it's noisy. Now, how to normalize this to the normal text? Because then only we can apply the existing well-suited NLP algorithms, right? So that we're trying to also solve. And is there any noise? Okay. Yeah. And mostly the thing is that as industry, we would like to understand the user feedback. So whenever we launch a product or something, and then the reviews go on the different website, like shopping website or the Twitter, people put the reviews. Then we try to solve these problems. Also, some problems that are nowadays Twitter people complain about, like customer service also, that we have provided over the Twitter that people send, and then can I automatically understand the problem and then try to solve them. So like chatbot, but using the Twitter on Twitter. So these are few problems that we work on and using the social media. Yes, sir. Yeah.
Okay, I think one question from say Santanu. Can you please which type of data sets can be used for task scheduling? So this question I'm not very clear. So Santanu, can you elaborate what do you mean by task scheduling? Okay, by the time okay.
So I cannot say about data set, but yeah, definitely we also solve the problem because this problem and this problem we try to solve using blockchain. And then using I don't know, I'm not working, but I have read about it. Some people that's task real and then the data set also, but
Uh-huh.
blockchain is really powerful in that area, and if you apply intelligence there, yeah.
So, as you know that, right, the kind of even for machine learning and the various social media analytics tools also,
Yes,
the kind of tools that academic like institutes use by the researchers and so on, and the kind of tool industry is using. Okay, you have already known both sides. Can you
yes, sir.
share some thoughts on that? What kind of tools you guys are using in the industry, and just for the benefit of the participants?
Okay, sir. So first, I'll prefer that the okay. First thing that comes with the research labs and the industry is a huge gap of financial gap, support gap. And that's why when I work as a lab, we work as a university lab, we try to focus mostly on the open source things. And then whether it's a limited support, but we try to go with that. But in industry, since they are getting revenue on that, high revenues, and then they have to sell that. So it's so they what they mostly will go with the proprietary solution. We'll try to get this open source, but if we understand that open source software do not have that kind of support, then probably we'll quickly uh, switch to that proprietary solution. So that is one thing. For example, but even though sometimes open source solutions are very good, like for example, Apache Spark or Hadoop systems, they are open source, but we can like use in the industry also, and then also in industry also. But the thing is that in industry, if I have to work in the industry labs, then probably I will build a system which can and directly use the Spark Spark. But probably as an industry, I can probably buy something from some big players, and then they have already have that capability. They have try to solve the problems which usually people have, and then they build up something platform on that, and then probably we can reuse and is the difference that we get. Yes, sir.
So, yeah, one question from one of the participant. The question is, which algorithm is used for auto ML?
Okay. So AutoML, AutoML is a pipeline. First thing is that, and then we can solve multiple things. For example, I can take for example, let's say if you want to uh, find the best algorithms with the data set. Probably you do not need to retrain again and again. We can have like pre-trained models, right? And then we can use them, and then probably reuse them so that we do not need to again train on with them. So that we can do. But algorithms, why it depends. I can recommend a paper which is called Efficient and Robust Machine Learning, which is for auto scalar, which is also an automobile system. I cannot share whatever we have done because it's a proprietary, but can read that way. So, for example, then the difference is like hyperparameter tuning, and the algorithms are mostly being used are Bayesian optimizations rather than grid search or random search based algorithms for hyperparameter tuning. And the Bayesian optimization, which is trying to, this is an optimization algorithm which tries to find the optimal points. So that's kind of algorithm that we can use. Yeah. But yeah,
So another related question is from Manisha. Can you quote an example of social media analytics using automated ML? Some
okay,
example of
okay. Okay. So this nice question. Now let me explain the difference between auto ML and ML. So there will so whatever we do is a machine learning part of it. So let's say for the text processing and everything. Now, what AutoML is a framework, a theory that we can say that design pattern that okay, can we find few things that we are repetitive in this and then try to automate this thing. So you need to build that. So that is what the auto. So whatever you do in social media analytics, from the text processing, trying to identify. Let's say, for example, I have taken already an example. Let's say suddenly you get an Facebook, let's say news feed and then your Twitter feed. Now, can your automation system decide that okay, no, I for this is an very this is kind of structured text. This is kind of unstructured. This is noisy text. Okay, my algorithm should be changed here, right? Okay, we need to process this way. So that is what we can do with AutoML and social media analytics. So
yeah, that,
it's eventually avoiding any repetition task that we know that okay, this will be there. We already know, and then we don't want to spend time. We know that we can get to Twitter feed, we can get a Facebook or news feed also. But how to decide that? We don't know, want to indulge in that again and again, right? That we need to build. So that is what the AutoML.
okay. I think there is another question, but this question I think may not be relevant, but Nilesh,
Okay.
if you have answer, you can provide. Otherwise, also we'll be discussing, giving some lights on this question in the last day. So,
Okay.
question is like, what are the various methods adopted for fake profile detection? Latest technology and advances. So, if you have some input on this, you can share. Otherwise, also we'll be having some information, giving some information on this on the
I
last day.
haven't, I haven't worked on this problem, sir, so I cannot like really give the answer to this. Yeah.
Okay. So I think in between, questions are coming, but in between, I also ask some very generic questions. Like say one, so you have already filed many patents, industry
Yes, sir.
patents, and so on. But and again, see in academia, um, so we don't have much expertise in filing patent and so on. Can you give some lights on what kind of problems, or say what kind of solutions or system can be patented? Can you provide from your experience?
Okay.
Can you give some lights on that?
Okay. So when we file a patent, first thing is that what we have to uh, say that, for example, the say creation of a bulb is not a patent. You cannot create like a bulb. You're creating a bulb. You cannot patent that, right? That's an invention. That is that. But it's a LED bulb. You cannot patent that way. Let's say okay. Let me come to more scientific. Let's say you find a mathematical equation. You cannot patent that. So, if you want to patent, whether it's a big or small uh, invention, it should have an application. If it do not have an application, it could not be patented. So that is one first rule. So any abstract idea or something that theoretical concept that they cannot be patented. They should be applied and then they should be patented. So that is one thing. And now there's so, and then it doesn't matter if it's a big or a small idea. So we can patent everything. Like, for example, that patent that has been published for me was a simple recommendation patent from IBM. So what it does is that given this is the recommendation for a data engineering. Now they so this so method would be one, but we use a one method, but the thing is the method was not patented. What we patented is what a system, that how can we build a system on that. So anybody, if using that idea, builds a system, that will be patent infringement. So that we can, like they told that they have written there that okay, this could be a data source, this could be a data type, and this could be this, and then this comes to the system, and then these are the users will interact and this. So once we have an idea and then application, then probably we can patent that, and then it goes to lawyers and the attorneys that try to find the way. You do not collide with other patents and other ideas. For our guidelines is that your idea should be applicable to the real world. Yes.
Yeah, very nice, Nilesh. So maybe one last question from my side. Okay, before that, there are some questions from the participants.
Okay, sir.
So this question, I'm not sure whether this information can be shared or not, but okay, that you just
Okay.
see. Can you brief, say, the works of Oracle in machine learning system, like say different machine learning applications in Oracle? Can you briefly mention some of the applications?
So I cannot talk about Oracle. Sorry, I have given the instruction that I should not talk about any product or anything.
Yeah, yeah, that is what I guess. But that we understand that
Uh,
is not a problem.
yes, sir.
Yeah.
Yes, sir.
So another question, I think this is again generic, uh, but
Yes, sir.
this may not be directly relevant to you. So can you suggest few data sets that can be used for ML experiments? Okay. So maybe I will take up this question. Uh,
Yes.
See, the data set depends on the underlying uh, problem that you are trying to solve. Okay, so as you know that machine learning today is applicable in possibly in all the say day-to-day problem that we are facing, starting from the something like say social media, say monitoring to some say purchasing some item from a commercial website, or some security applications like detecting attacks in the computer and so on. So I think when you have a data and you want to find some mine some pattern from the data, then there is an application for machine learning, which can be either supervised or unsupervised, or say reinforcement learning framework. So I think, but data set should depends on the underlying problem. So depending on the problem, so there are many repositories where you can download freely available data sets. So we are also planning to share some of the web links from where you can download publicly available resources. So maybe that we will be providing. Okay. So another question from one of the participant is, okay. Can he explain any real problem that can be solved by machine learning system? Okay, so that again, this is very generic question. Maybe Nilesh, you can just see if you have, if you can give some light on that.
Okay, sir. So, sir,
And,
if you, yeah, so machine learning system, we can, let's take an example of Corona itself, right? So, first, at the first phase when it started Corona, whereas we don't know how does it impact and then what are the different aspects of it, right? And then we slowly started building data sets, which was like the John Hopkins University, and then they made it public, and then people started to researching on and analyzing that data, right? And analyzing the data that okay, how does age affects that? How can continent or the weather affects that? All these things or what is the duration? All these things, and does it like is it different for India and China? That's it. So this was the first part was the data analysis. Now again, for example, now we all know that vaccination could take a huge time to have to be there. So when once we are like in February, March, there was like, can we repurpose any drugs that can be like that can be used for treating the corona? And now that is a problem of machine learning that we can use. Like drug repurposing is a problem of machine learning. So the thing is that even before going to for the trials, so on not the human, even on the mice trials and other animal trials, but can we get some insights? Okay, this kind of drugs are used for this symptoms are there, and this symptoms are there. These are the kind of virus structure there, and then so and that analysis and that has been done by the machine learning systems. And so this yeah, so that's kind of things that we can do. The real world researchers they're working on the how can we like solve like cause and effect relation and then probably drug repurposing that these two could be solved with the machine learning and at least it can help to give the insights so that actual the people who are working in the labs in the bio labs they can use that insights and then solve this problem in a faster yeah that could be one example that have seen nowadays.
so Nilesh, there are some
Yes,
more questions. So
yes,
I'll read one by one.
yes,
So
sir.
one of the question is if you have answer to this, you can share. Otherwise, tomorrow in one of the session, this part will be briefly covered.
Okay.
So how to collect data from multiple social media platforms? Does that data need to be stored?
I guess sir, you can give the better answer to that because you're working on this like for many years. Yeah.
So,
Yes.
so no problem. So the participants. So we are having a special session tomorrow,
Yes.
mainly on this collecting data from different social media platform and then how we process those data and so on. So I think we will take
Yes.
up these questions again tomorrow. Then again, and the next question is: are there any library in Python for dealing with social media analytics?
Okay. That's a nice question.
Mhm.
Yes. Social media analytics.
Yeah, so one beauty for
Mhm.
Python is I think Python has become so popular. You have solution for any problems. So if you talk about social media analytics, you can think of say problem in maybe four different domains. One is like say content. In the content, you may have something like text, and you may have something like video and the images and so on. So in the text part, you have various tools like NLTK tools for NLP related problems, then scikit-learn and so on is for classifiers. Okay. Then another side is for video, but which video I'm not very sure about the say library. The name of the library is, as I'm not much aware on the video and image side. But when we try to process this video and image, we are using Python in the lab. We are using Python-based open source tools. So the name of few tools I can provide, say in tomorrow sessions. Then again, another site is something like, say, network analysis, because in social media, in addition to the content, you have relation between various entities like users. If you take Twitter, say Facebook, for example, you may have connection between user to user as a friendship network. You may have connection between users as a say as a kind of by hobby or by school or colleges and so on. So there is a scope for analysis, say network analysis. So then again, we have various Python-based network analytic tools like Network X is one of them, SNA and so on. These are, say, very popularly used network analytics tools. Mm. Okay. Then one another side of analyzing the network is again users' behavior and the log. So then user behavior log assess, there is no dedicated tools, but this can always be transformed into either say network form or traditional learning form. So yes, that also can be good. So in Python, I think it's like you have solution for everything, starting from very core Python programming to very specialized problems. So I think Python, that is the kind of beauty of the Python. So you have limitation of using Python in terms of efficiency and so on. So I think you have various uh, tools. Okay. So I think another question is okay, which means okay, what is the means? I'm not very. The question is not very clear, but let me try to read out. Which means was used in storing data in the past before coming of big data. I think he's trying to ask before big data, what are the kind of method for storing data?
I guess earlier the thing that we started with like file systems, then again relational databases, and then eventually we started moving to the NoSQL and others like the problem, the thing is that earlier we had systems, but the thing is that but they are very costly, and then the big data revolution we like store or process the data with the community hardware, which are very low cost, and then we keep getting new ways, new paradigms of para programming. There's a map reduce, and then that uh, distributed processing that your program should travel to data, not your data should travel to program. So this way the programming paradigm has been changed, and then also the people worked on rather than solving these problems in for example, all right now mostly we try to find uh, any algorithm which could be distributed and try to build the algorithm in that way, so that that our processing has been done properly. So that is earlier we had system, but they are not very cost effective, and then we started. So this is what the big data.
Okay, I think one last question from the participant. I think this is again very generic questions. Okay, normalizing the tweet language. I think the question is it normalizing the tweet language is different from the normal document? So question is not very clear, but I feel what he's trying to ask is normalizing tweets and the normalizing some general document, are they same or different? Uh,
Okay. So they're definitely different because, for example, if I go here and then then probably help me there. But the thing is, the first thing that we see that if you write a in regular text, then probably it has supported by some grammar. So there's some inherent structure that we can like there's a that is inherent structure, grammatical structure, and which can say that that is following a particular pattern. Now, if some data set or something is following a particular pattern in a very good way, then probably we can extract the information or we can learn from that insights from that. But then the Twitter, something that people usually don't follow the grammar. Then the problem is the vocabulary. Now, so the vocabulary, let's say, where are you going? And so now you know that R is article and you, all these things. So you can identify each everything. Now, and Twitter, when you write, then they will write RU. Like, RU as continuated, and there's R and U, single R and the U. Now, how can you define that it is not ru? And that's the problem. How can we separate the vocabulary? These kind of things. That is that we call it NY. These are kind of differences. Also, I guess the amount of data that we get, the text, if we follow data, then we can build a proper context and we can identify. But in like Twitter, short text and with the noisy text, the structure is not maintained. Somebody writes like we talk, we write that way. And then it's not so now the thing is that earlier you're thinking that okay my context should like two words before, but now I don't know where it is, and I need to also find which gives me the context. So I guess these are the problems that we have. Am I correct, sir? I don't know.
Yeah.
Yeah, but yeah, I face these problems while normalizing them, so that I don't know.
Okay. So from the panel members, if you have some um points to discuss with Nilesh. Okay, I think from the panel members there is no questions, and maybe that was the last question from the participants also. So Nilesh, thank you very much, yeah, for your nice presentation and very close interaction with the participants, and it was kind of a very insightful presentation. Thank you very much,
Yeah,
Nilesh.
yeah. Thank you, sir. It was great to connect back to IT Guwahati. Yeah. Okay, thank you. Yeah.
So to the participant, we will start our next session at 11:10. So we will have a break of 10 minutes.
नीलेश नंदी सर बोल रहा हूँ
अरे सर गुड मॉर्निंग सर कैसे हैं
Good morning. Nice to see you here and helping us. That's
sir anytime sir I am very happy to come back to IT Guwahati anytime.
great.
Yes, it's like whatever
You
I
are
am.
doing well, I think. You are doing well.
Yes, yes. So it's
Great.
all of blessings. So what I am doing with now is just because of all of you.
Okay.
Yes, yes.
Okay, sir. Good to see you here.
Sure,
Keep in
sir.
touch. Sir.
Sure, sure. Thank you, sir.
Thank you, sir. It was a very nice session. I thank you for this wonderful session.
So dear participant, yeah. So we'll start next session at 11:10. But let me just briefly give an idea of what will be the session about. So Dr. Bidut Patra will be taking the next session. in the area of like a recommendation system in problems in social media platforms. So yeah, we'll wait for about 7 minutes and to start his sessions. But in between, if you have some uh, query or some suggestion that you have, you can please communicate to the chat. We'll try to see how to. Um,
Uh,
Sir.
so we can inform to the participants that last half an hour, we'll have this panel, what it's called, discussion on future
Panel
perspective.
discussion.
Uh,
So one of the some of the queries from the participants are like, what are the open problems in the area, open research problems. So to give some lights on this, we have planned about half an hour session in the last day. So we'll have yeah, after the last session.
around 4:15 or 4 to 4:50.
Yes, yes, yes.
So anybody has anything to ask or any information to know, please prepare your. You can give questions beforehand also. We'll try to set up that time, or you can prepare your questions and come up that time. So this is basically one kind of validity come feedback come question answer session with panelists for direction in this social media analytics. Is it okay, Ranbir?
Perfect, fine, sir.
So this is for information to all participants. Please prepare yourself. You can message before that. We can look into it. We can discuss that time. Vidyut, can you share your slides? Check. Working on now. Ranbir, start.
Yeah, your
Can
slide
you hear?
is yes, yes, yes. You can put in the full screen.
Yeah, yeah. Can you hear me?
Yes, yes,
Can
yes.
you? Can you? Huh? Yes. Huh?
Yes, yes, you are audible.
Okay. Okay.
So,
This time,
once
show
again,
your face. Before starting, show your face.
Okay.
Then you can switch off the video. Okay, continue. Ranbir, continue.
so once again, good morning to all, and welcome to the second session. So, Dr. Bidut Patra will be talking about a recommendation system in location-based social network. So, before starting his session, let me take the privilege to introduce him. So, Dr. Bidut Patra is a faculty member in the Department of Computer Science Engineering, NIT Rourkela. He received his PhD degree from Computer Science Department, IIT Guwahati. He is also a recipient of Marie Curie Fellowship from European Research Consortium for Informatics and Mathematics, and he did his postdoctoral research from VTT Technical Research Center, Finland. He has been working in recommendation system for maybe more than 10 years now, and his research area includes data mining, machine learning, anomaly detection, recommendation system, education technology, etc. So he's also executing many sponsor projects from industry as well as from the government agencies. So Bidut, with this brief introduction, yeah, I would like to thank you for agreeing to the sessions, and the session is yours.
Okay. Good morning to all. This is my privilege to be associated with this faculty development program at IIT Guwahati. So I am really thankful to Professor Ranbir Singh and to my PhD thesis supervisor, Professor Sukumar. So with that, today I'll give talk on recommender system in location-based social network. So it is little deviate from the topic, but I think it will be okay for all. So today outline we'll talk about here introduction to recommender system mode, and then we'll talk about the recommender system used in location-based social network. So here we go. So this figure shows that a person wants to purchase a headset, but he is bit confused with the so many items and so many varieties of the product for the same kind of the product, so many variation of from the different manufacturer and so on. So therefore, this is like we have a plenty of information, and we don't have the time to see the each information and what is what and so on. So this is something called is the information overload. So information overload is a scenario where the consumer is really confused what to purchase and what information needs to be consumed and so on. So to rescue this information overload problem, we have a system is something called the recommender system. Yeah, recommender system basically help people cope with the information overload in the now digital era. As you can see, there are many products from the Amazon. It is not only the headphone, there are products like from the electronics gadget and then the item which could be used in the gardening and then computer accessories and so on. And then we know that say Amazon may have a million, more than million of the products. May I need maybe say a few products. So how to choose those products from the out of the million product. So this is all about the recommender system is here to help the user or consumer here. So application of recommender system across the domain. So started with say movie lens data, movie, and nowadays for the streaming scenario, that is something called the OTT streaming scenario. Recommender system is heavily used, and of late they started using the recommender system e-learning domain and many of us see observe that that Coursera also send the recommendations, and then obviously we are familiar with the Amazon recommendation and so on. So the Netflix, Amazon, YouTube, Spotify, Book Crossing, and Yahoo Music, these are the business house. They use the recommendation heavily used, and the TripAdvisor and so on. So here there are recommender system was first introduced. The first seminal paper was introduced in 1994 from MeitY that I will talk about later. But here is we can see the overall view of the various recommender system. So we can see here that there is something on the left side. We can see the content-based recommender system. So content-based recommender system needs, if you go off in the hierarchy, so it needs the profile of the user and item. What does it mean by the profile of the user and item? Let's say, so when you talk about the movie will have the genre, and then we'll have the say who are the actors and so on. Or say if you talk about the product, say let's say shirt, what will be the color of the shirt, and those are the item profile, or they say those are the item profile. On the other hand, user profile is something like that is myself, whether I like the romantic movie or I like the horror movies and so on. Those will be the say characteristics of the person. So that is something called the user profile. And whenever user needs to whether needs the recommendation, so they need to register with this set of information in a system. So these are the starting of the recommender system. That is something called the content-based recommender system. Basically, it explores the content information of the user as well as the item. So now come to the middle one, that is collaborative filtering. This is like very nice intelligent algorithm system is collaborative filtering. It does not need the information of the users or item information is not required. Why? In the case of the content-based filtering, item information getting profile from the item is really difficult. Let's say talk about a multimedia a movie. So in a movie, it's really difficult to find the what is called is the features of the movie. Why I'm saying so? Let's say many of us might have experienced that nowadays whenever we are searching for a particular movie in YouTube, what we see is whatever the content is written, it is not that movie. So people intentionally write some popular movie's name and then popular movie's name, and therefore we may not get the actual content, actual movie which one we are searching. So this is another problem with the content-based recommender system. So content is not all. So on the other hand, what is developed over the time is something called the collaborative filtering. In collaborative filtering scenario, as you can see in the middle, that is collaborative filtering. So it is supported by two databases. One is the rating database. So as we are habituated with whenever we purchase some product from the Amazon, so then what we see, they ask for the, can you give the rating of particular product? So this is nothing but the rating for the particular product. Let's say in example, user E1 has given the rating on the item I1 5 and so on. So this is something on pure collaborative filtering actually use only these rating data set. It never use the all other information. So and it overcome the problem of the content base. And on the other hand, it is mixing everything. So use whenever you have the content, so better to use them and then come up with a new recommender system is something called the hybrid approach and the hybrid recommender system. So overall, all the recommender system at the end of the day, it predicts some rating, and the rating is say above some threshold, and then those are the recommended. So this is the overall overview of the recommender system, and we'll more focus on the collaborative filtering. As I said just before, there are a few advantage. There are advantage over the content-based collaborative filtering has the advantage over the content-based filtering. So, and then collaborative filtering is widely used. Even 2003 report says that Amazon also, Netflix use the collaborative filtering. So move to the next one. So we'll talk about two basic recommender system algorithm. That is something that comes under the collaborative filtering. Collaborative filtering again can be divided into neighborhood-based approach, and another will come as what is called the model-based approach. In neighborhood-based approach, that is there are something called is like user-based and item-based collaborative filtering. So left side you can say is something you can see that is the user-based collaborative filtering. So user-based collaborative filtering was first collaborative filtering introduced in 1994 by Resnick Fall from the MIT. So you can see on the left side, see these are the users. We have the users and their choice. So dark arrow indicate that first lady, she has rated those 1, 2, 3, 4 items. And what we want to do, can you recommend the item to the last guy? That Graves, can you recommend that item? So that is the recommendation. How it works. So if you see carefully here, so first what we'll do it, say that we'll identify the user for whom we need to recommend them. We need to recommend, and then we will find the what is called the friend of this guy. And if we get the friends, then we'll see the what are the likeness of that guy, and then accordingly we'll recommend it. So on the other hand, we'll tell this one in more detail in next 2 slides. On the other hand, in item based, so it is like which item will be recommended based on the item's neighbor. On the other hand, in user based, that item will be recommended based on the user neighbor. So that's why the name comes is around user based and the item based. Now we move to the next in detail. We'll talk about the user based here. Let's say, as I said just a few minutes before, we are talking about the collaborative filtering. Here left side we can see a rating matrix. And then let's say we want to predict rating or we want to recommend the item to U4. As you can see that U4 has rated 3 items and there are 2 unrated items. So now question is which item, whether I4 or I5 will be rated to user U4. What do you do it? First, we'll find the neighbors of the user U4 with the neighbor of the user U4. So therefore, what we need to finding neighbors, we need to find the similarity between the user U4 and the all other user who have rated the item I4. In the question here, we can see the I4 is rated by U1, U2, U3, and U5. Among this set of users, we'll find who are the neighbors, means where the similarity value is greater than 0 or greater than some threshold. Once we got this information, who are the neighbors or who are the friends of the user U4, then we can compute the rating. Then what we can do it, we can compute the rating using the formula given here. This formula is nothing but this RU is nothing but what is the user average rating, and then is weighted differences, and then this is weighted sum, and then weighted sum is nothing but the similarity between user U and the neighbors. We can move to the next one is item based collaborative filtering. Now in case of the user based, we talk about the user's neighbor. So in case of the item based, we'll talk about the item's neighbor. Here so find the similar item of the target item which are also rated by the active user. Let's say we talk about the same user U4. What we do it? So we want to predict using the item-based collaborative filtering, what will be the prediction for the item I4 in case of the user U4. So what you do it, we'll compute the similarity between I4 and the all rated item. And let's say out of the 3 rated items, 2 are very close to item I4 in a sense that they both are similar. And then we take the average. So for let's say I2 and I3 are very close to I4, and then we take the summation average. So therefore, it rating will be 4.5. So that is all about the item-based collaborative filtering. So it was introduced in 2003 by Caprice and Server from University of Minnesota in the year 2003. So now we move to the different kind of okay. So now we talk about, just few minutes before we talk about the similarity. So there are some traditional measure for computing similarity. So that I will just name a few of them. One is Pearson correlation, as we know how to compute, and then is the Jaccard similarity between two user sets. And problem is Jaccard similarities, it does not compute the rating values. It does not consider the rating value. Similarly, cosine and adjusted cosine. Adjusted cosine is same as the cosine similarity. Only difference is that here the as you know, the some user are very strict, some user are very liberal for giving ratings. So those needs to be considered, and that is considered in case of the adjusted cosine similarity measure. And moreover, for information, adjusted cosine similarity is used for computing similarity between the item. As you can see, the similarity between I and J are the two items. Whereas the Pearson and Jaccard or other similarities are used for the computing similarity between two users. So we talk about the neighborhood-based approach. Now that another direction of collaborative filtering is model-based approach. So in case of the model-based approach, so I will talk about only two algorithms here. One is very popular algorithm. This is something called slope quant predictor. It appeared in 2005 in the conference SDM. So so here, this is very simple algorithm here. So there are two items, item I and item J. Let's say item I has the rating 1, whereas item J has the rating 1.5. And what is the difference between two rating? For 1.5 minus 1 for the user A, it is 0.5. And then can we predict the rating for the item J for the user B, of item J for user B? So this is nothing but the 2 plus whatever this that is what is called the difference. So that is the 2.5. So this is all about the slope quant predictor. So it find the deviation between item I and item J for the all users rated both the item. So that is the deviation matrix it is found from, say, let's say user I and J. So once we got the deviation matrix, then what we did it, so this is nothing but 2 plus, whatever the difference, so this is same thing. So instead of 2 plus, because user may rate the many more items, so then we take the average of the item plus what are the deviations we obtain, what is the deviation we obtain for the target item to the all other rated item. So this is all about the slope one. And then there are fine modification of the slope one is something called weighted slope one. So in the previous equation, what we saw key there was no weight. So now they are weighted. Weighted it's like is the number of user rated both the item. And then there are improvement of some previous algorithm is like bipolar approach. So instead of taking the all deviation, so the deviation can be divided into two group, like one wherever the like item, like is nothing but the whenever the rating is above the average user rating, and obviously other way is the dislike item. Another very popular approach in the model based approach is the metric factorization approach. So here, so actually neighborhood based approach is very intuitive and it is very easy to implement. On the other hand, metric factorization actually it gives best results, or it gives better result with compared to neighborhood based approach. Obviously that results depends on the how you evaluate it, and then evaluation means ME or RMSE, whatever the value, it is found that metric factorization work better than the neighborhood based approach. What is idea here? Suppose as we said that collaborative filtering, in case of we'll have a rating matrix, and we can see that there is a rating matrix. And ideally, this metric factorization, it decomposes this matrix into two lower dimensional matrix. And then in this example, we can see here the matrix size is 5 into 6. So we can divide this matrix into two lower dimensional matrix. One is 5 into 3, another is into 3 into 6. So this is something called the user features. So ideally, essentially what it does, the item and user are placed in the same space and both are treated on the same set of features. And then it finds, say suppose one example, and then essentially we don't know what is the name of the features. Let's say one example. So genre can be treated in the features of the item, or maybe people like what kind of movie. So this is something on features where the user particular may have the likeness or dislikeness. Similarly, particular movie may, whether it is inclined to a particular genre or not. So this is something called the latent features. So in this example, what we see is we have the matrix here, and then we got the two decomposed matrix here. And then essentially, how do we find the rating at this position cross or user one and item one? So this is nothing but the dot product of these two vector, that is item vector and user vector. So this is all about the matrix factorization. Essentially, it minimizes this equation here. So this is the rating value, that is the actual value, and this is the predicted value as PU and QI, and the rest of the thing are the normalized, what is called regularization parameter. So ideally this regularization parameter, and it is improved upon this PU QI. Why there is need for improvement? Let's say the Titanic movie, essentially it gets the very good rating. Let's say it gets rating 4.3. And what is the average rating of the database? Let's say 3.8 and so on. So then, but there is some user who is very strict user. He does not give, as you know that many faculties are very strict and other faculties are quite liberal for giving marks. Similarly, here also for rating also some users are really liberal and some user is very strict for giving rating. So to consider this fact into account, so what it is done is that bias is introduced, and bias is computed is something what is the differences from the mean, and once you compute the item bias and then user bias is computed. This is the way that matrix factorization works. So next we'll move some other aspect of recommender system. I don't know whether I am going fast or slow. So another aspect of recommender system is something called the long tail item recommendation. So long tail item recommendation is something, actually, see, let's say it's Titanic movie, everyone likes this movie, and these movies are like popular movie. So for those movies, actually there is no need for recommendation to tell any user, okay, you go and watch the Titanic movie. So but there are huge plenty number of, okay, thank you. So there are plenty number of use item in any say e-commerce business house that is hardly it receives the rating. Those item are called the long tail item. It is not actually 80% item receive very less number of rating, where 20% item receive the most of the rating. So this is something called the long tail item. So but present day recommender system hardly they focus on recommending the long tail item. So this might be another research challenge for recommending the long tail item. So of late people started working on also the long tail item. So second issue is the cold start user. This is another problem that we'll see in the location based recommendation also. Cold start user means, let's say I am the new user to the system. So system does not have any idea who am I. So how the system will recommend? Another is the item. So let's say new item is introduced, or Amazon introduced a new movie in its what is called streaming platform. So how the user will be knowing that there are new movies, and then how the system, it's not the user, how the system will be knowing, because system will be knowing only if there are ratings here. As I said, that system, current system are very biased to the item which gets the more rating. So this is another scenario, the cold start and the user item recommendation, cold start scenario. But ideally, the cold start scenario is addressed using that content information, using the review information or content information, or maybe extracted information from the other source. Then another issue is diversity. Let's say, yeah, once I purchase the any, say, let's say mobile phone. So if the recommender system again say me, okay, you purchase A50, okay, can you purchase like another mobile from the another product? So I may not need that product again. Rather than maybe I will be very liking to get a book written by Tagore and so on. Can the recommender system really suggest that kind of what is called is book or item? And so that is, there should be diversity of the item. Otherwise, end of the day, when we see the recommender system is always recommending the same kind of item, then it is really difficult at a point, at certain point of time, maybe user might be disappointed and they may leave the system, a recommender system. I don't want the recommendation from the system anymore. So therefore, but most of the recommender system, they focus more on similarity. More on similarity means more on accuracy, and therefore diversity is neglected. Then obviously that year from 2010, people focusing on diversity also. And there another interesting challenge is group recommendation. What is that? Group recommendation is something like that. Okay, so obviously that people say recommendation is always personalized. But let's say we are studying together. So can you watch a movie? So today evening, so that with 3-4 guys, can recommender system can talk anything about that group activities and so on. So that is, or maybe we can move on a tour. So obviously people are afraid to move. So that is something group recommendation here. And streaming scenario, streaming recommendation system. Let's say present day system or most of the recommender system, they focus on the historical data. But let's say in a scenario, let's say for in a Amazon, so same product is being purchased by many guys across the globe. So therefore, if you don't change those information in the database obviously that information is getting changed. But whether recommender system is taking account those changes or not. So that is something called is recommender system in the streaming scenario. So we need to compute the user preferences on fly. And then the last current trend is something called the session-based recommender system. See, I don't like to log into the and then purchase, or maybe I don't like to Netflix and then purchase. I will be very happy to purchase the product if I as a guest. So can in this scenario recommender system is able to give the recommendation. So that is talk about the session based. So I come and then I will enter without giving my credential as a guest, and then can recommender system can give the recommendation on fly. Like I'm seeing one mobile phone, and then can it really give the cover of the mobile phone in the next session? So this is something called is the session based recommendation. And then community based, and nowadays we are mixing with the social network and so on. So utilizing task and social media information can be exploited to give the recommendation on for new friend and others. So these are the area here. Now we'll move to the goal start item recommendation. Just I said already here. And obviously deep learning has been used to learn the item and user features profile, and this is all about the session based recommendation already covered, I think. Come to the topic here is something called social network here. Since mobility is a basic need of the human being. So, and we are now in this pandemic situation, we are oftenly irritating sitting in the home. So therefore, so mobility is very important aspect of human life. So it has a very high degree of freedom and variation. Analyzing of this data extracted from the movement of individual over a period of time give some insightful information about the person and so on. So various spatial temporal component involved in the human mobility. Which location I visited and how far is that location from my place and how many times I visited the location. So these are the aspect of the mobility of human being. And and then we have the important source. Obviously, collecting this type of information is really difficult. But nowadays it is so easy for collecting this type of information because of the social online social network. And then along with that, we have the growth of internet, and then we along with that we are generating the huge information. So social network have the largest user generated content, and sharing real time experience on social network is really the current trend. So some achievement I really like to share, and say along with that, this is up to this one is very fine about social network. But see, whenever we call someone, we ask very oftenly is where are you right now? So it is not always key, it is also essential part to know actually at right moment where I am. So maybe I am in office or maybe I am home. So before talking also. So in social network, so when we are writing, so my achievement, let us include the information where I am in the right moment. So that is something called the location-based social network. So we have the social network. So let us incorporate the location into the social network, and that is something called location-based social network. So add the new dimension to the social network. So this is something called geotag, user-generated media. So we can post the information, giving the information that where from I am posting, or we have the say GPS information, it automatically fetch the information where from I am, and that is embedded into the social network. This is all about the location based social network. And then there is, as you can see from the 2 point location and the trajectory. So I am moving from one location to another and then so on. And I am giving the information in the, and the automatically check-in information is available there in the social network, and that can make a trajectory. So what we can do, we can analyze the trajectory for the various purpose. If see even some locations, if I miss it or intentionally or unintentionally, if I miss the the particular check-in information, that can also be extracted out of the analysis of the trajectory. So this is on how good it is when you embed the location, as I said with the example of the phone. Here we have the virtual, we are talking with some guy, when we know that is, oh, this guy is talking from the London, it will be very easy to visualize what is actual scenario. So that is something called the location-based social network, basically bridge the gap between the virtual world and the physical world. Location-based social network, here we share the location embedded, as I said earlier, and then location-based social network has a facility is called the check-in facility. So a facility is to share the time and location publicly. So using this check-in information, we can extract the trajectory of the user, and then we can analyze here. So there are popular social network. One is Foursquare, and obviously we have the Facebook Places, and we know the Google Map, and there are plenty of social network. Many of them we don't know. So these are the more popular, most popular, widely used location-based social network. You know that user visited different locations on the left side, you can see, and from there what we can do, we can generate the correlation between the user to user, and we can place in a graph, that is user to user graph. Similarly, so location to location graph also we can generate, that is something on the right side, we can see the location graph, and we can use the graph mining technique to know about the user preferences, or maybe the point of interest for a particular person, or maybe in general. So in the research area in location-based social network, which we point out some of the portion here, that is, one is point of interest or location recommendation, friend recommendation, event recommendation, and content recommendation. Basically, I will focus on the point of interest recommendation in this talk. So what is the difference between whatever we studied just few minutes before, that is item versus POI recommendation? So here users remain fixed. There was also user, here we have also user, but there was, we are talking about the item. Now we'll talk about the point of interest, that is the locations which people may likely visit that location. So personalization is the primary factor in any recommendation. So following are explored in the both item and POI recommendation. What are those? So that is implicit rating, that is content information. Popularity, popularity means in a particular location many people are visiting, let's say Taj Mahal, so that is no need to tell. So that how good that place is. Okay, so that is the popularity. Similarly, I talk about the item, so those are also explored in both the cases, but which was not similar to in case of the POI. Interest recommendation, geographical influence. So this is like really play an important role. So that is something called the geographic influence. That is the demographic information. I am sitting in Raurkela. So if someone recommend a restaurant in Guwahati, it is really difficult, right? So that is something called the geographical influence. So proximal location is, yeah, that is geographical influence also is matter like whether I am sitting in metro city or I am sitting in like other city and so on, or urban area or so on. That is the something called the geographical influence. Another is the proximal location. So obviously, I will be very likely to visit a restaurant which is very close to me. Something called proximal location, and selecting the expert user is very challenging. So many places when we go move to the say in a particular location, before searching a particular hotel, what do we see? We go to the trip advisor. So what they actually many expert users are saying, expert user in a sense that they have the experience of they are giving more reviews, or they have the experience. So those are something called the expert user. And obviously frame-based collaborative filtering needs to be explored in case of the point of interest. Because see, if me and other guy are visiting in the same location, church every Sunday, 11 o'clock, that means we'll have the same interest. So that is something called here we say is the friend. Now, what is the general approach to this problem? So memory-based approach is the same as the neighborhood-based approach. So in POI-based collaborative filtering, and then metric factorization also has been explored in location-based social network, or yeah. And then obviously we have the hybrid approach. So as you know that in social network or any point business house group which has the Facebook pages or location-based social network or any other place or Google page. So what we can do, we write the comments and reviews, we give the tips and so on. So those information can be explored for providing the recommendation to the user. So in the early work in 2010, so by this, it was appeared in ACM GIS conference from the University of Pennsylvania. So they talk about the location recommendation for location-based social network, that is the friend-based collaborative filtering. So what they did, it compute the social friend by applying the Jaccard similarity between a pair of users. So how the users say, it is like how many common locations are they visiting by two users. So this is something called the they talk about they are the friends. So once they identified the friends of a particular user, so they apply simply the user-based collaborative filtering, finding the rating on the non-visited location. So as you can remember here, this is nothing but the weightage in case of the user-based collaborative filtering, that similarity computation was user to user, let's say using Pearson correlation. So here we compute the similarity between friend between friend. What is UK? UK is nothing but the friend of the user UI. And then how do you compute the friend, whether someone else X is friend or friend of me or not? How do you compute? So we'll see the any location we visit, so whether both of us visit the same location or not. If there is at least a location where that we visited most, then he will be the friend. So that is the once we get the friend list for the each user, then we compute the similarity between the friends and the active user. In this case, example active user U, and they compute the they use the cosine similarity for computing the similarity between two friends. Once we compute the friend and then compute the similarity between friends, and then we compute the rating. And as I said, the rating is above some threshold. So this is something this summation is over the similarity value, and then and then rating is above some threshold value. Then we recommend that place. So this might be the point of interest for you. Continue with their work. So instead of saying all friends, so they said is why can't you introduce the what is called is the proximal friend. So nearby friend to train to share more common visited location. So therefore what they did it, so distance they have taken into account, and they put in a power law distribution formula here. As you can see here, x is nothing but the distance from the active user or to the other friends. So please remember that friends is like if they visit at least a single location visited by both of them. And then they use this one. If you apply the log on the both sides, then it will come in a very simple and very nice linear equation. And from the cross validation, they compute this this value of wj and wy, and then finally they compute the similarity here. And then this will be the rating similarity between the user UI and UK, and then we apply the formula, previous formula here for finding the rating. Continue with the friend-based collaborative filtering in other work in 2000, probably in 2011 by the same guy. I forgot the name of the conference. So, so in user-based CF, rating similarity of the friends are considered. Friend-based CF exploit how the active user is influenced by the mobility of its virtual friend. So what they did it, now they come up with a solution here. Why can't you match these two important aspects? One is what is the friend. So this is also a Jaccard formula here, and along with the location they are visiting. So friend can be computed in many ways. So as I said, from the common locations or whatever we can do it, we can compute the what is called is similarity and so on. So and then alpha is a tuning parameter that ranges from 0, 1 that can be computed using the cross validation. And once we compute the similarity and then we can have the rating, it is quite similar as the earlier one. Yeah. So in 2013, so a location-based collaborative filtering is exploited. So what they ideally they did, they apply the user-based and item-based and they combine it here. So assume that the user visited similar location. So what they did, first they apply the user-based collaborative filtering and then they apply the item-based collaborative filtering. How they computed the item profile? Here item is nothing but the POI, point of interest profile. So what the POI for each user, it is nothing but a vector of the, and the size of the vector is nothing but the number of user in the system. And then they found the score for particular, what will be the score or what will be the rating for a particular location for user U. What they did it, find the cosine similarity between item to item. Here item is nothing but the location L. Here item is nothing but the location L. So you compute the similarity between the location L, that is the, you can say that we can say the target location, and the all other locations visited by the user U. It is the same style of the item-based collaborative filtering. And then another factor they added, that is the weight WUL dash. What is WUL dash? So it is nothing but how many times, that percentage of time that that guy, that person U has visited that particular location L. So here is WUIL. So UL dash, it is the same thing here. What is that? So this is the frequency at how many times they are visited over that particular total number of frequency in a particular location. So this is the output of the item-based collaborative filtering, and then we immediately will get the same information from the user-based collaborative filtering, and they finally combine it. So now we'll talk about the cold start scenario in case of the location-based recommendation. So personalization depends on upon the historical data. As I said, if I am new in a recommender system, traditional recommender, and I don't have, and the system does not have any idea about who am I, that means my interest and other where from I am, demographic information, no other information. If the system does not have, then it is really difficult to give the personalized information. Let's say quite a simple example. Let's say if I say, can you tell me what are the subject one student ideally should read at the semester 3 or in BTech Computer Science? Then I can tell a few subjects. I can tell a subject based on the curriculum. That is something called general assessment. So it cannot be personalized. Once I know the students, I know which part he is weak or she is weak, then only we can give a personalized. If you know the interest of the guy, that means I know the history of that guy, and then only I can give the personalized information. So a new user does not post in historical data, so that is a really challenging, and such scenario are called the cold start scenario, as I said. So there may be two types of cold start scenario in case of the LBSN. One is called the user cold start problem. So I am the new in location based social network. Another is the new stadium came up in a particular location 1 month before. So that might be new to the system, and people are not visiting that stadium, or people are not visiting that restaurant. So that will be a point of interest cold start. Now, for user cold start, user having no historical data, that as I said, and POI having no historical data, are never selected for the personalized recommendation. Now, under that item cold start, in case of the POI cold start, we'll get some scenario here. So user having no historical data, I generally use the say location-based social network when I am in a say in Raurkela, but I move to Mumbai for some task or for some business work. So can the system really tell me what are the point of interest for me? So that is something called new city problem. I have the information in my home city, but there is no information in the new city. So here also come the POI long tail. It's a similar fashion in the as I discussed in elaborately in case of the in recommendations. So here also we'll have the unpopular POI are never recommended. So that is because no one is going to that restaurant, no one is giving the tips and so on, but that restaurant might be a good one. So, and then many cases, what we exploit the users, expert users information here. So now I will show you graphical representation. So what are the scenario might be for in case of the say POI recommendation on the left side. So I am the new user. I want the recommendation. Okay. So I want the recommendation. So I want the recommendation. Okay. So another is in the new city, expert maybe he was the expert in your home city, but he is not expert. Expert in a sense he has the knowledge. He has visited many places, and that information is with the system. And then expert also may ask in a new city, and the last one is the normal user. How do we handle this for scenario here? Having said that, we can move in some other direction. So instead of only on the rating, but we have the plenty of information. Like say in the a business house may have the Facebook pages, a Facebook page, and there may be people are giving, commenting, and so on. So those information, those review can be extracted for recommending the POI. So that is the another one work. And how this work happen is like, and nowadays that sentiment analysis is taking a big role to understand whether the people like this place or not. So therefore, there is a work in 12, I will tell you the references there. So they exploited the sentiment for providing the recommendation. So this is the standard technique they use here. I'll talk about, this is recently introduced, this work is like modeling user preferences, exploiting the metric factorization. So what we have the user information, and user gave the rating on the various point of interest. So then we'll get these metrics as you can see, and there are green block indicates that there is no rating for these users. What we can do, we can exploit the metric factorization, and then we can fill this metric, incomplete metrics, we can make it complete, exploiting the metric factorization technique. And then what we do it, say for user, we get some information here. Let's say it was, as you can see, this location, that is U1, F1 was green. Now, once we extract, we get some information here. Now, out of this user row, what we can do, most cited, most rated feature we can extract. So let's say here F2 and F3. So what we can understand from here, that user very likely user uh, uh, they like these two features, F2 and F3. Now question is, how do we get the features from the POI? As I said, in each POI we have the reviews, and extracting the review we get some features, and then we fill them, and then we got this important feature for each users. So features with high ratings are considered, top W feature for each user are identified, and user preferences over features are identified. So similarly, what we do it in earlier case, if you see here, earlier case, what we did it key user and features matrix. Similarly, what we can do it, we can replace the user with POI features. So in this matrix, even though this matrix seems wrong, and it is indeed, so instead of U1, it should be point of interest and the feature. And then what we do it, we use the similar technique for extracting the features, and then top features are extracted. So at the end of the day, what we are doing, for each user, we are choosing the top features, and for each POI, we are choosing the top features. And once we got this information, then what we do, we can recommend the full start user. As I said, for the full start user, we don't have the features explicitly, we need to exploit the reviews. And then what you do it, this is the representatives, is nothing but the, what we do it, for expert opinion we can take. And similarly, it is not sufficient to only the expert. So we choose the top L influential user, top expert, top L expert, and then we have come up with a solution here. So as you can see, is like, so that we user has rank very close to 1, will be given more weightage for his rating. And finally, for normal user, what you do it, then for expert user is considered as he has the rating information, so we can do simple user-based collaborative filtering. And obviously, we can incorporate the distance formula as we did earlier also. And then we use the data set, like a set of data we have used, as you can see. And we did not use all of the data. Some of the data we use here. And then in other IR techniques, recommender system also, or any other machine learning technique, we need to evaluate it. So we evaluate with precision and F1 measures. Obviously, we have DCG or normalized DCG. And then conclusion, say, we talk about very popular recommender system, and then we talk about some open research direction in recommender system, especially the session-based recommender system, and people are using mostly deep learning technique for exploiting the session-based recommender system. But recent work shows that even the traditional approach is much better than the deep learning technique. So that might be another research challenge to establish that traditional technique is much work better than the deep learning technique in case of the session-based recommendation. So obviously another challenge issue, we talk about the streaming scenario in recommendation. And then in case of the recommendation in location-based social network, as you must have observed that time factor is not considered here, and performing a subjective analysis on how the poll start POI of a city are perceived by the poll start user of the city, whether I like that stadium or not, that needs to be also taken into account. And so whenever I am visiting Taj Mahal, very likely I will visit nearby places, and maybe their new stadium came up within this time, so I may visit that place. So that is the utilizing the neighboring non-call start point of interest for estimating the probability of the target user to visit the start point of interest, and recommending neighbors events based on the user interest. Sorry, recommending neighbor events based on the user interest. So with this, these are the few references here that I can share, and then I acknowledge my help to my PhD student Pramit and Rama Samula, and with that I think I can end my talk. This is my email ID, and maybe that slide might be available in my Google site. Done.
Yeah, thank you, Vidut, for very detailed and a nice presentation. So we will take questions from the participants. So there are some questions, I think. One of the question is, how does recommendation system deals with changing user preferences? So question is like, does the recommendation, how does recommendation system deals with changing user preferences?
Yeah, that is I said is like a recommendation in streaming scenario. So it is traditional system is really very difficult, because if you talk about the neighborhood based, it needs to computation of similarity measure. So ideally, essentially, what is done is that similarity is pre-computed. So therefore, so there are very little work on that. So what they did it, so similarity they compute, but the similarity computation should not take even the order of n. So the complexity of the similarity value, they use the say locality sensitive hashing kind of technique to find the quick similar user of the active user taken into those rating changes. There is a paper appear in CIKM in 2018. So they use the locality sensitive hashing for computing similarity between two user, and paper is IBM. I forgot the name. Anyway.
So there is another question. Can you please explain the collaborative filtering, mainly the user-based and item-based recommendation algorithm again?
Okay. Acha, in a short, I can tell you ki we know that is the what is called is neighborhood based what is called is classifier, right? What is called nearest neighbor classifier? Yeah, nearest neighbor classifier. Essentially, nearest neighbor classifier, what we do? So if for a new item, what we do? We find the similar item, and based on the similar item class, we identify the class level of the new object. So here also we do same thing whenever we compute the user-based collaborative filtering. So let's say for user U1 we need to provide the recommendation. What we do it, we find the user's neighbor using some similarity measures, and we see what are the rating provided by those neighbor and then we take a aggregate function. We use aggregate function, and then we say what is the prediction, and then accordingly we recommend. So similarly, in case of the item based, we do same thing, but instead of user's neighbor, we use the item's neighbor.
Okay, I think that has answered the question. And just to supplement, hello.
Ranveer, you are telling something?
Okay, I think that has. So there are some more questions. So one of the question is, thank you for the wonderful talk. Can you please talk on group recommendation in PO context?
Group recommendation is not much explored area in general, but I don't know much on PY recommendation in case of the group, but that might be a good research topic. But there are some work on the group recommendation. They see, so let's say three friends, will have the information of the each one. So there are three guys. So now we'll form a group. Should I continue?
Yes, please.
Okay, so three guys, they're forming a group. What we can do it simply. So in a particular movie, what the rating was there earlier, so we can take an average. So there are different techniques. What we can do to satisfy all in the member. What do we do it? We take the list of the all ratings. Sometimes we take the maximum of the all ratings, or sometimes we go for the average. So these are the starting point for the group recommendation. So it's not much explored by me.
Okay, and I think we'll take another 3 questions that are already submitted, and the rest, I think we'll, because of time, we'll not take another additional. So the question is, can you please explain how Amazon choice is given and how reliable it is? So I think it's a industrial algorithm may not be publicly available, but in general, we can share.
Yeah, actually, in 2000, that's why I say in 2003 there was a paper. They clearly tell that they use the neighborhood-based approach. Okay, for providing recommendation in Netflix. Okay, but of late we do not see any paper that how actually they provide the recommendation.
Okay, and in just to supplement to this, in recommendation system in data mining, we also have something called association rules mining. So association rules mining frequent patterns are quite heavily used in recommending item. So you can also look at uh, association
Yeah,
rules. Yeah. Next
right.
question is, how can I or we get suitable ML models for the proposed solution? Are those models already created? I'm not sure what is the reference to the proposed model. I think it might be some proposed models from one of the proposed model in your slide.
Okay. There are actually some open source recommended system. It was not there earlier, but 2018 onwards, I forgot the name, but there are open source recommended systems. So one can look into those open source recommended system.
Okay, one last question. Can we trust all the reviews and rating given in the shopping website? Okay, this is one interesting question.
Yeah. Actually, there is another research direction of recommended system. Obviously, even Ronwin can answer this one. But just to inform the community of recommender system, is there is another topic, but it is a very neglected topic in part of recommender system. Of late, we are seeing only 1-2 paper, but earlier 2005 to 10 there was paper. Is something called attacks on recommender system. It is something like giving false rating to say popping one item up or maybe making the item down. So that may be another direction, but it's very difficult to tell me exactly because I'm not much in sentiment analysis. Maybe Ronbir can answer.
No, and many companies will be engaging many paid person to provide buyers recommendation also. So sometimes say recommendation on say if it is not third party review, then if it is, it might be high chances of getting bias. I think one more last question it is there. What are the most popular recommendation system in the online shopping websites? If you have information, maybe you can share.
I didn't get you. What
So
is
what are the most popular recommendation system in the online shopping websites?
okay? What are the most popular recommender system used in online shopping
Websites.
Okay, again, it's like it's difficult to tell. But in academics, I think user-based or metric factorization is quietly used recommendation.
Yeah, and in the afternoon session, they will be looking at of the matrix factorization. So I think that they can also see. Yeah. So, Bidut, thank you very much. I just check with the panelists if they have some comments or query. Panel members.
One Vidut,
Yes, sir.
nice talk. Very nice. And
Thank you, sir.
how I use this in social media analytics? You remain little bit silent. Can you explain a little bit?
I talk about a location-based social network, but in case of social network, maybe friend-based recommendation is performed using some recommendations techniques.
Trend.
Friend.
Okay. How there can be utilized?
There it can be utilized. Probably they utilize some recommendation technique for recommending the, or maybe social link also they can use. I'm not very much sure.
Okay, that's good. You are also working with Flipkart, correct?
I got fund for we had a talk on session based recommendation. So that is why not any collaborative work.
Okay.
Okay, sir. Just to supplement to your comments. So if we so recommendation system or recommendation method can be defined in a very generic manner. So in that case, it is applied in many applications. Something like searching, a recommendation of a document to the query in the search engine, products,
Yes.
and various like even the say friend finding in the say
He
in
had
the
mentioned.
Facebook or something. Then advertisement with the website, many advertisements are pop up. How do you recommend and so on? So
Okay.
there are
Yeah.
so I think recommendation and system and the social media, they are very closely kind of connected. Okay. So
Yes.
with this, yeah, thank you very much, Bidut, for once again for the very insightful and say presentation and a talk. Thank you very much.
Okay. Thank you.
Okay,
Thank you.
we'll meet at.
We'll meet at 2:30 for the lab session. And today, we look at the fisher engineering. We'll focus on the fisher engineering aspects. So many of the questions that participant asked in the previous sessions are like say overfitting, how to take care of overfitting, underfitting. Okay, so fisher engineering has a very close relation with the say with handling overfitting, then underfitting, and so on. So we'll look at the fisher engineering dimension reductions and different methods of doing this in the and the building say classifier that we built yesterday after reducing dimension or after selecting good features. So see you at 2:30.
Bye.
Bye. Ganendra, are you able? Can you test your audio?
Sir, I can put my share my.
Okay. So now you are connecting from two sessions. You are connecting from mobile, right?
Yes, sir.
Mm. So can you see this share content screen? Oh, okay. I think I have been made as the presenter. I think you are still not the presenter. I will probably request
Oh,
Naresh to make it as you
I
as-
did, sir. I did, sir. I just did.
Oh, okay. Can you try now?
okay. So, yeah, here it come. Okay. Is it coming?
Yes, yes. It is coming.
So is it visual?
Yeah, I can see. Yes, yes. It is showing. You are showing the collab, right? Yeah. It is visible. Huh? Can you
Okay.
perform some operation on this?
Yes, sir.
Yeah, I can see your screen. I think it seems it is working. So then it's fine. So fine. So I will join around 2:30. Okay.
Okay. Oh,
Mhm.
then I'll listen.
afternoon, Sharon. Welcome back.
Very good afternoon, everyone. Uh, we will try to start the second lab session. So I think participants are still joining. Maybe we'll wait for 5 minutes. Maybe 2:35 will start. Yeah. So once again, good afternoon to all the participants. So as we mentioned yesterday, so in yesterday lesson we have seen, given a text corpus, how do we pre-process the data and create the vector space model representation, and then build the classifier, different classifiers using the vector space model representation. So today we are going to focus on two important topics. One is called feature selection, another is called dimension reduction. So in the previous sessions, we have already seen what is the importance of feature selections and dimension reductions and so on. So today we'll try to see, discuss some of the feature selection methods and some of standard dimension reduction methods, and how can we, even the same data set that we have used yesterday, how can we the features and then reduce the dimensions and recreate the same classifier that we have built yesterday and see and compare the performance between the two. Okay, so I think still few participants are still joining, because this few say initial discussion on these methods might be important for understanding the program. So maybe another 2 or 3 minutes I will okay. In between, let us. You have any query related to yesterday's discussion? So one of the question from one of the participant is regarding yesterday's session, testing with two different sentiments. The prediction is both 1-1. Did I make a mistake? So I think you might have done correctly, but since the features that we have used, okay, since we have not done any feature selections and feature selections, many of them, those features might be noisy. Okay. So let us see, after doing feature selection and reader, you can again check are there any changes. So if you are using the same program have uploaded yesterday, then you are doing perfectly correctly. And but because of the presence of noisy features, you might not be getting correct classification output. Did anybody face a similar problem? Let us start. Okay. So a similar format that we followed yesterday. So first few minutes, about 45 minutes or so, we are going to understand these different feature selection methods and methods without much technical understanding. Okay, so because considering the different background in the participants, so I will try to say discuss the topic or present the topic as less technical as possible. So, but whole idea is going to be like how this say feature selection method or dimension reduction method works in the high levels, and when we actually select the features or reduce the dimension, we should be able to visualize what has gone inside the methodology. That is the keeping that motivation. Let me try to keep as less technical as possible. So to start with feature selection, in the literature, if you see, you may find feature selection in maybe three major classes. One is something like filter methods. So in the filter method, what we try to do is like we try to understand the characteristics of the individual features, okay, without actually building the classifier. So before building the classifier, we want to see this, some statistical analysis of the feature or some characteristics, and based on that, we want to say whether this feature will be useful or not. So that is, so there are various methods under this filter method as well. But some of the common methods are like mutual information, chi-square distribution, Fisher score, variance threshold, and so on. Okay. So these are some of use say filtering methods for selecting features. And as I just mentioned, in the filtering method, we do not build the classifier for selecting the features. To explore the characteristics of the features and decide whether this will be or not. Another class of feature selection is called wrapper. In the case of wrapper, you have to actually build the classifier, check whether the selected features are good or not. Something like first you will select some set of features and check whether these selected features are with that selected features, how is the performance of the classifier. Then you will either remove some features from or add some features to that and check whether the change in the performance, and accordingly you will select features. Okay. So in the wrapper method, you are actually going to build the classifier using the target features and decide whether you should select or not. So wrapper methods will be a very good strategy, but it may not be practically applicable in domain where you have lots of features, because building classifier itself is a very expensive operation. So in like text where you have thousands of or millions of features, so wrapper approach is quite not suitable for say in very suitable. And another class is called embedded methods. So the concept of embedding method is that, or embedded method is that we know that the features defining the samples are not having same importance, right? They might be having different importance, right? So we want, so at present the say method that we have used yesterday, right? We are considering all the features equally important, but it may happen that so different weights of features important. So that is the concept idea here. So idea here is for you using some learning methods, you are going to check what is the probable importance of each of the features, and those features which are not very important, you are going to assign very less weight, and that you feel found to be important, you are going to assign very high importance, and so on. So for every feature in the data set, you are going to determine some weight vectors, and weight vectors you are going to penalize those less important and so on. So this embedded basically means you're going to create a vector with the say weight that you are going to consider. So these are the so you can in the literature, if you see, you'll find say feature selection method like in these three broad categories. So I'm going to start with some of the very fundamental and say classical filtering methods. Like these methods are used in the very beginning of the say feature selection approaches, and they provide a very nice conceptual idea why how a feature selection approach should be. So keeping that in mind, I am selecting few of the say classical uh, filtering methods to explain say how do we select features. Okay. So again, before that, feature selection, the whole idea is, as we keep on repeating in the previous discussion also, in the feature selection, we are trying to remove features, and in the dimension reduction, we are going to project high dimension to the low dimension. Okay? These two are different. So by doing so, by removing the say less important features, or say by projecting to the lower dimension, quite often we remove noise present in the data sets. So by doing so, we can also address overfitting and underfitting. Okay. So one question yesterday, right? About overfitting and say underfitting. So and the say dimension reduction also can some of the overfitting or underfitting problems. So let us mutual information. This is one of the very initial feature selection methods. So before understanding mutual information, and something called entropy. Okay, so instead of slide, just make it as an interactive session. I am trying to use the file so that I can edit and communicate with you. So in the mutual information, before understanding mutual information, we need to understand something called entropy. So let us see what is, many of you might be aware of what is entropy. So entropy of a random variable, so I'm referring to the a random variable x. Entropy of a random variable, say entropy of a random variable, we basically says that it tries to estimate the amount of uncertainty of an event in the random variable. So when an event happens of these random variables, how much uncertainty convey, okay, that event has, that is what the say entropy. Okay. So if you look at here, entropy of this random variable x, so when you say random variable x, it's having many elements. From this capital random variable x is having something x1, x2, and so on. Many samples, you may have something like n here. So these are the elements of this random variable x. So random variable of this random variable, entropy of this random variable x is nothing but so uncertainty of each of the element. If you take the uncertainty of every elements of this random variable, okay, and take expectation of that, in of that, okay, that is what the entropy is. So the of this entropy is nothing but summation of minus summation of probability of this small x, where x is the elements of these random variables, log of p of xi. So what is this log of p of xi? Okay. Log of I, that basically means, so if you see here P of X, what you here, this is nothing if I say log of this. Okay. So this is nothing, this is something like, you also have minus here. So in information theory, entropy is coming from something called Shannon's entropy in information theory. In information theory, so there is something called information content of an event. Okay, so if I have random variable x, and let us say this small x is an event in say random variable, then information content of this event, information content of happening this particular event x. Okay, this is defined by 1 by probability of. So this 1 by probability of x is the information content of an event in this random variable. Okay. If you have some clarification, please me by through chat. So if you look at this, and this log is for basically for scaling factor. So when I have this log of 1 by px, this is what is equal to minus of px, log px, because log 1 by px will be minus px, right? So this is what so this minus in entropy is nothing but because of this 1 by px. Okay. So this part, so in entropy, the second part, log px, represents the information content of the event x. Okay, and you are taking mean of this information content. That is because if you multiply, this is nothing but expectation. Right? Multiply this by probability. This is nothing but the expectation of the expectation of this of all the elements, all the events in the random variable. So nothing but the average information content of the events in these random variables. So that is what the entropy. Okay, so this entropy is defined as the something like uncertainty. So let us try to understand what do we mean by this uncertainty. So let us try to explain this uncertainty using using some examples. Let us assume that you are performing some activities. Let us say you're tossing some coin, for example. In tossing coin, you are getting head and a tail and so on. Let us say if you are having, and this is unbiased coin, let us say. So then if it's unbiased, you are going to have the probability of getting head or probability of getting tail is like very close to 0.5 or something. So when you have a coin with the with the probability of getting head as 0.5, and you are asked to toss this coin again, then I'm asking you to predict what will be the output of this coin tossing event. What is the probability, whether you'll be getting head or whether you'll be getting tail. Because there is a 50-50 probability, I'm not sure, I'm very uncertain, right? That is what this one. But let us say instead of unbiased coin, if you are having a biased coin, say probability of getting head is close to 0.9 and the probability of getting tail is close to 0.1. Then if I ask you what will be getting if you toss this coin, then uncertainty is quite less. Say with 90%, I can say that it is going to be head, right? Yeah, that is what we mean by uncertainty. So if you have a kind of probability of 0.5, then I am not sure whether you'll be getting head or tail. So lots of information content, lots of uncertainty. And if I know that lots of uncertainty or lots of information content, because you do not know what is going to happen. So whenever something happens, it is the new information that you are getting. So if you are having a probability of 0.9 or say probability of 0.9, and you are when you toss it, you are getting head. Then head, you are already expecting head, right? You're already expecting head, and you are getting head. that means there is no surprise or uncertainty. So in getting head, you are not getting any new information. So you are not getting any new information because you are not having you are having very less uncertainty, right? Very less information you are getting. So, but when you have say a 0.5 probability, you do not know what you will get. So when you get something, you are going to be information. That is what we call as the information content, the amount of information that you receive from this event. Okay, so that is what. So I'm trying to explain this by this plot. So if you look at for the same coin tossing, the entropy curve will look like something like this. Okay, with the change in the probability. So change in the probability of getting hit. If you say starting from 0 to 1, if you change the probability, the entropy curve will look like this. So what does it mean? From this plot, you can easily see that when you have the 0.5 probability of getting head, that means you're also having 0.5 probability of getting tail. That time you have the maximum entropy and you have maximum information content or maximum uncertainty, maximum amounts of surprise whenever you get an event. But if you look at the origin point 0 point, here the probability of getting head, that means you are getting probability of tail as 1, right? So with this probability, if you toss, I'm sure that you will be getting tail. So there is no uncertainty, there is no surprise. And you can also see that entropy is 0. Similarly, when the probability become 1, there is no uncertainty. Right. So this is what the entropy curve for binary events. Similarly, you may have for say in any number of events, and say you will be getting highest entropy when the probability of getting those event equally likely. Okay. Always in the when you have the equally probable, you will have maximum entropy. Okay. So why this entropy is important is that entropy conveys lots of useful information, summary information. So when we said that you have a random variable and entropy is very high. So when I say you have a very high entropy, I know that say the probability of different events are equally likely. Right? So let us try to take this example. So let us say these random variables are nothing but the terms present in this your corpus. In your text corpus, you have a collection of terms, right? Those unigrams that you have used yesterday. So if I say that entropy of this text corpus is very high, what does it mean? It means that uh, the probability of occurring all those features are equally likely. Right? So when you have equally likely, say, features, then there is they are not very useful because the same term will be occurring to all the classes. So if we say that the entropy of this text corpus is uh, very less, that means there are some features which occur very frequently in the datasets, and there are some features which occur very infrequently in the datasets. So that is the kind of skewed distribution of the features. So this kind of information I can get if I know the entropy. So from this, I can also guess what might be the probable quality of the features. Okay. So this is entropy. So now entropy can also be, say, joint entropy, so which can be defined as this expression. Likewise, you can also have conditional entropy, which can be defined something like this. So now, having understood what is entropy, what is mutual information? So mutual information try to define relation between two. Suppose if I have a random variable x and you have a random variable y, then the amount of information to random variable shares I want to measure. So in mutual information is one such estimates. So in the very terms, if I want to understand mutual information, this is like if I know X, how much information about Y you are able to receive from X. Similarly, if I know Y, how much information about X from Y. This is so this kind of common information that receive from other event that is kind of understanding of the mutual information. So let us say we have two close friends, for example. So if I know that okay, they are very close friends. So if I know one of the characteristics of the one friend, then very likely that I am understand some of the hobbies or some of the characteristics about the other friend, right? If they are very close, they will have common hobbies, common eating habits, and many things will be common between them. So that kind of thing I can capture. So mutual information between X and Y can be defined. Please look at the second line. Can be defined as a summation over X and Y with joint probability of X and Y and the log of this component. So if you see here, this small x are the elements of the random variable X. What are the y's? They are the elements of the random variable Y. So in this equation, if you see second terms, second component, the log of joint probability divided by probability of X and the probability of Y. So this second term is it tells the relation between the element x and element small y. In the random variable capital X, you have X. In the random variable capital Y, you have this small y, and this second is telling how close the element X and element Y are. So this second term is called point-wise mutual information. Point-wise mutual information try to define the relation between the one element of one random variable to another elements of the another random variables. Then multiplied by the joint probability of X and Y, right? So what is this? Again, this expectation of this point-wise mutual information. That means information between X and Y is okay, random variable X and Y is nothing but the expectation of the point-wise mutual information of the probable elements pairs between X and Y, capital random variable X and random variable. So this is the expectation. So this is what the mutual information. So when you mutual information, it is nothing but I can understand how much information it conveys by the other events. Okay. So this I can also why we discuss entropy is that this we can understand in the form of entropy again. Mutual information between X and Y can be entropy of this X minus conditional entropy of X given Y. So internal meaning of this I will probably leave as a homework to the participants because of the shortage of the time. So this is what the mutual information. So now let's see how to select features using this mutual information. So let us try to see that. So here I am trying to how to use mutual information to select features. So let us refer this example where we have considered unigram as the features. Okay. So here in this expression, I'm trying. I'm using symbol U and C. U is for the selected features, which can be in our case, which is nothing but one unigram, and the C is the class, whether this is the positive sentiment or negative sentiment, something like that. So C is the random variable defining the class level, positive or negative, and U is the random variable defining occurrence of the target features that you want to analyze, whether the feature is present or it is absent. So this random, you have two random variables, u, and you have another random variable c. So this u random variable will have presence or absence of the feature that you have considered, and the c random variable says the class level, positive or negative. Okay. So if so, this mutual information, if you just define, so this is same expression, joint probability of small x and y, and the log of this. This is the same mutual information. So when you estimate this, what I'm going to get is I'm going to get what on average, what is the probability that this features is related to this class. So if I say good as the features, what is if you have a very high mutual information between good and the positive sentiment class, it basically means that they share lots of information between the occurrence of good and the sentiment class level positive. So when you say we are selecting mutual information for feature selection, that is nothing but we're trying to find estimate this. What is the probability of the random variable for the features and the random variable class levels? If this is very high, that basically means they share very strong bonding. Likewise, I can find for every features, I will find the mutual information with respect to all the classes, positive class and negative class. Then whether this feature is a good feature or not, that I can see by estimating, taking the average of positive class and negative class, or maximum. People use maximum or average to assign the say score for individual features. Okay. So this is how mutual information can be used. Another say commonly used method for scoring is chi-square. So in the chi-square, if you remember, chi-square distribution tried to define the independence of two events, right? How independent two events are. So suppose something like that, if I want to estimate, I can use chi-square. So in this chi-square definitions, like if you have observed some observed frequency, you have some expected frequency. If the observed frequency and expected frequency are say you are very close, that means you are expecting something and you are observing the very, exactly what you are expecting. That they are not they may not be independent, right? You are expecting something and you are observing something, then you are not actually getting what you are expecting. Then the two events might be independent. That is the idea here. So chi-square basically try to define the how independent two random variables are. So now, so the same assumption, if you consider random variable as the features and another random variable as a class, you try to estimate what is the chi-square for between the features random variable and the class random variable, which can be defined as something like this. Okay. So this is the chi-square. So if this score is very high, they are independent. Occurrence of these features and class are independent, otherwise less. So this is again another chi-square feature selection method. Likewise, feature score is also another feature selection method, but so this I'm so likewise you have other feature selection methods like features variance and so on, and so when you talk about this filter method, you have seen that you are not actually building the classifier. Before building the classifier, you're trying to see the characteristic features, and based on that, you're trying to select. So so this is what about a filter. So in the wrapper, so in the wrapper, what we'll do is we'll build the classifier itself, then we'll check the performance. So in the wrapper, you may have say two standard wrappers are like something like backward pass and the forward pass. The backward pass is nothing but this recursive feature elimination. So what is the recursive feature elimination? It is like you consider all the features and build the classifier and check how good it is. After that, you remove a feature one by one. Say, let me remove the first feature and build the classifier again and check what is the performance. If the performance that you get after removing this first feature, if it is better than the removing, then I will say I can probably remove this feature. So likewise, I will remove individual feature one by one and check removing which features you are able to get better results. So then I will probably remove features that gives the best performance. Likewise, after removing the first, next again you try to remove another features that will improve the best and so on. So in first you consider the entire features and remove one by one. Build the classifier and remove one feature, build the classifier and check the performance, other features and so on. If you do that way, that is the backward pass or recursive feature elimination. Another is you instead of starting with the first features, you start with the single feature. You consider one features and check the performance, and likewise you consider the second feature performance and so on. You consider individual features and check the performance and select the features gives the best results. That is the first feature of the first feature that you are going to. Then after selecting the first features, you try to add second features to the selected features in incremental manner. You add the second, so from the first feature, you will try increase to the second features, third feature, and so on. You move in the forward pass, and you add the features that will increase the performance. That is what the wrapper. Likewise, people also use genetic algorithm for wrapper and so on. So in the embedding, as I just mentioned, it tries to learn a vector to penalize the individual methods. So in the lasso or L1 normalization or regularization, they try to use the L1, something called L1 regularization to learn the weight of individual features. For that, it used something called gradient descent and so on. Since we have not discussed about those approaches, technical details I am leaving for you to explore. But just to give a notion, this is going to learn a vector to assign which importance of individual features. So with this brief understanding, so we have, so feature selection will identify the good features or bad features and select the features. Okay. So this is about feature selection. If you, before moving to the dimension reductions, if you have any questions, we can take up that. Okay, so if you do not have any questions, let us see what is dimension reductions. So in the dimension reductions, I am not going to throw any features out. Instead, I am going to project high dimensional features to the lower dimensional features. Something like yesterday, we 12,000 number of features, right? Let us say I do not want to select features. I don't want to throw. Instead, I just want to project those 12,000 features to something like 100 feature space. Everything I want to project to 100 feature space. So that is what the dimension reduction. So there are many dimension reduction methods, but two of the classical approach that one need to understand is one is called principal component analysis, PCA. Another is called say something like LSI. LSI and the PCA are two of the say popular methods. In addition to that, there are other methods as well. Okay, so these two methods works using something called matrix factorization. So today I'm going to discuss ISEA and the LSI. Why I have taken these two is, if you understand one method, you can understand the without much difficulty. So that's why I have chosen PCA and LSI. Likewise, you can also have neural for reducing the feature space that we call as the embedding in the deep learning. So let us see what is PCA first. Principal analysis. So before understanding principal component analysis, we need in the matrix algebra something called eigenvector, the eigenvalue. I'm sure all of us are aware of these two. So just to recap, but however, for those who are not just what is eigenvector and eigenvalues, just to recap, let us see what is eigenvalue. Just a brief definition. So I'm just trying to define what do I mean by eigenvector. Let us say I have a matrix A. Okay. Then let us assume that I have a vector X, and I also assume that I have some scalar. Let me just use say C for scalar and the vector X. So X is a vector, C is a scalar, A is the square matrix. Okay. So for a given square matrix, somehow if I can find one say scalar C and vector X, and this form can be created, then we said that C is a eigenvalue, C is an eigenvalue, and the X is one of the eigenvector of C. Okay. So this is what the eigenvector and the eigenvalue. So X is a eigenvector, is a vector, and the C is the eigenvalue. Okay. So if matrix A is having order of something like n by n, like n rows and n columns, the number of eigenvalues can be up to n. Okay, that means you can also have different eigenvectors, n number of eigenvector for each of the eigenvalues. Okay. So this is what the eigenvector and eigenvalues. What is the significance of this in terms of representation? I think there is one question. Participants, let me just see what is that. How feature selection is useful for soft detection? I think this is a very particular question. Maybe I'm not aware, but feature selection, irrespective of the target problem, in any learning model, first thing that you need to do is represent the samples. What are the features? Okay, so software fault detection problem also, prediction problem also, you have to visualize how do you represent those instances that you want to predict. You'll have some instances that you want to predict, right? So how do you represent? So from that representations, you have to use some features to represent. Then the moment you have that, you can use say feature selection method to identify whether this feature is a good or bad. That is the kind of generic framework. Otherwise, if your problem is very specialized problem where you have some kind of personalized features, then that may also be selected. That is, some expert will say that these are useful features. If you have such expert, if you do not have expert, then I have to use such kind of estimates to select. Then, so going back to eigenvalues and eigenvector, let us try to see what is the importance of this eigenvector and the eigenvalue. So what is eigenvector? Okay. So as I just said, if you have the dimension of this is n by n, you can have up to n number of eigenvalues, and the largest eigenvalue is known as the principal eigenvalue, right? And the eigenvectors corresponds to that eigenvalues are the principal eigenvectors. Then second eigenvalue is the second principal eigenvectors, and the eigenvector corresponds to that second smaller eigenvector is the second principal eigenvector. So principal eigenvector corresponds to the largest eigenvalue. So what is this eigenvalue means? It's like, let us try to visualize some points, like let us try to visualize, say you want to take, you have some points in space and you want to take projection. Suppose you have say I have space something like this, okay, and I have some point. Just to simplify, I have a point here and I have a point here. So in the, if I say that if I I have these two, and I want to represent these 2 points by this the line that I am drawing, for example. Okay. Then what I will do, I will take the projection of this point on this space. So when I take the projection of this point on this space, maybe it will lie somewhere here, right? So for both the points, if I take projection here, it will be quite it will be overlapping. That basically means these points, the projected point will not be separated, right? But whereas if I take another line, something like this, take the projection on this. So you can see that these 2 points will be projected on this line and they will be well separated. So in, if I ask you which one of this line can represent these 2 points better, I probably will say the second line is can represent these 2 points than the first line. Why? Why? Because the projected point are well separated in the second case. In the first case, they are overlapping. So from the projected, I do not know how many points are there since they are overlap, right? So I'm telling that second line is representing better because these points are well separated. So with this understanding, when I say when you say eigenvectors are like this kind of vectors, this line, so which can be in any direction, okay, which can be in some direction, something like this, and so on. Let us say if we say this is one of the eigenvector, when I take this projection on this line, how well they are separated? Okay, that's scatter, the variance of the points of the projected points that is represented by this eigenvalue. Large eigenvalue basically means the projected points are well separated. That is the point. So when we have the principal eigenvector, that basically means along that line, if you take the projection of the points, they are they have the best scatter, maximum scatter. That means the points are scattered in the best manner. That is what the principal eigenvector intuitive understanding. So let us try to understand this using another example. Okay. Let us say, just try to visualize, you have one object in front of you and you are trying to take photo. Using a still camera, you are trying to take photo. So you can take photo from different directions, right? And it may happen that from different angle, if you take, so for a particular angle, if you photo taken from a particular angle, maybe probably capture the maximum information, and you can easily identify what is the object from the photo. And it may also happen if you take a photo from a particular angle and the points are so overlap that you are not able even to say what is the object that you are taking photo. So which one is the better? So the first one is better because you can easily identify the object from the photo. Second one is not good because you are not able to identify. So principal eigenvector is like the particular angle from which you can capture the image of that object maximum, right? So these photos are nothing but projection of those points, right? Projection of those objects. So now, so angle is the principal eigenvector, like a principal eigenvector. Then from this photo, still entire image, entire information of the object cannot be captured because backside you probably from this photo backside you cannot capture. Then you can, so some of the information are not able to capture by the say photo from this particular angle. Then in order to capture the remaining information, maybe I will go to the other directions and I capture that. So the particular angle that will capture maximum information of the remaining information is second principal eigenvector. Likewise, from first eigenvector and second eigenvector, you might be able to capture maximum of the information, but still some of the information might not be might be still missing. Then you go to the another angle from where if you take, then the maximum of the remaining information is captured and so on. Okay, this is how principal eigenvectors, maybe in a very layman terms, maybe I can elaborate. So from this, I can say that if I know the principal eigenvector, and if I know the second principal eigenvector and so on, and I take the projection, then maximum information is already captured. Then remaining, the information captured in the remaining eigenvectors might not be very significant. Okay, that is the whole idea for this dimension reduction. Okay, so in the dimension reduction using matrix factorizations, this is the kind of very layman way of understanding. So one of the very popular method for finding this, working with this eigenvalue, something called eigenvalue decomposition. This is the matrix factorization. So in the eigenvalue, this is the eigenvalue decomposition. So what EPD does is the same thing what I just explained. So if you have a say square matrix A, and using EBD eigenvalue decomposition, I can decompose A into Q sigma Q inverse, where one say square matrix and the sigma diagonal matrix. So in the using EBD, square matrix can compose into Q sigma Q inverse. What is this sigma? The middle matrix. So middle matrix, nothing but the diagonal elements of the middle matrix are the eigenvalues. Okay, so the largest eigenvalue will be the first one, A1. Second largest eigenvalue will be the A2. Third largest eigenvalue will be the A3. Likewise, in the decreasing order of the say value, they will be arranged in the diagonal elements. Then in the Q, the first column vector, this B1, is the eigenvector of the eigenvalue A1. Likewise, second eigenvector, second column vector B2 is the eigenvector of the second element, second eigenvalue A2, and so on. This B3 is the eigenvector for A3. Similarly for this Q. So this is what the eigenvalue decomposition. But if the matrix A, if this matrix A is symmetric, okay, then what happens is this matrix and the positive semi-definite, then the eigenvectors that you are having, they will be orthogonal. So there are theory behind it, but just to understand that for this session, you please understand that if you have a symmetric say matrix, the eigenvectors will be orthogonal to each other. So if your these rows are orthogonal, if it is orthogonal matrix, the inverse of the orthogonal matrix is nothing but the transpose of the matrix. If A is a symmetric matrix, now instead of Q inverse, it will be Q transpose. Okay. So this is what. So now what I have is what I have here is I'm assuming that you have one symmetric matrix, and you are decomposing using the eigenvalue decompositions, and then you have this Q sigma Q transpose, where sigma is the eigenvalues in the decreasing order of the values, and the first column is the eigenvector of A1, second column is for A2, and so on. So this is what the eigenvalue decomposition. So the moment I have this eigenvalue decomposition, what do I mean by the dimension reduction is just one brief high level understanding of dimension reduction is. So the way that we are going to reduce the dimension is like, instead of selecting all the eigenvectors, I'm just going to select few principal eigenvectors. Okay, if I say that now in this particular examples, there are 3 features. So if I say that instead of I just want to reduce to 2 features, then what I will do is I will just consider the A1 and A2, A3 will be removed. Okay. So the moment I removing means I just assign 0 to A3. The moment I assign 0 to A3, this is like this column is removed. The B3 is removed from the, and this B3 is removed from the Q transpose. That means if I remove this, the only features will, only column eigenvector that will be removing will be V1 and a V2. Okay. This is how we are going to do the dimension reduction. So in the dimension reduction using matrix factorization, is if so you are going to perform the factorization and only select those eigenvectors to represent the samples. Okay, that is the idea behind this dimension reduction. Okay, so this very idea is used in something called PCA, principal component analysis. Okay, so in the principal component analysis, so let us try to understand in the kind of simple manner without much technical understanding. Okay, so so now this is exactly what you are going to apply in the on the data set that you are going to use in the experiment. Okay, so so I'm just for a simplicity, I'm just trying to create these samples and the feature vectors. Let us assume that I have a training data sets. So each row here, okay, represents each sample. So this first vector space for the first sample, second row is the vector space for the second sample, third row is space for third sample, and so on. So I have something like around 15 samples here. And how many features I have? I have 2 features, S and M. These are the features. So if you have 4 features, I will have 4 number of columns. If I have 3 features, I will have 3 number of columns, and so on. So in our yesterday examples, I am having something like 12,000 columns and 1,000 rows. Okay. This is what I have. Okay. So in the principal component analysis, the first thing that I'm going to do is take the covariance, construct the covariance matrix of this matrix. Construct the covariance of the matrix X. So here I'm assuming that you know what is variance and what is covariance. Okay. So variance is like given a set of elements. Variance is like how elements are scattered around the mean, right? So likewise, covariance is nothing but from the mean point of that another variables or the random variables, how the other points are scattered. That is the covariance. So if the covariance become positive, that means they are dependent to each other. Like if one random variable increases, another also will increase. If it is negative, if they are kind of opposite, if one increases, another will decrease, something like that. Say if I want to predict relation between the amounts of hours that the student study and the mark score in the exam, for example. If we say covariance between the hour spent and the marks are positive, that means more the hour the student spend, more is higher is the marks. Less the hours say student spend, lesser is the marks. So this is a kind of positive correlation, positive relations, right? So if when the covariance is positive, that kind of thing will happen. Suppose if they are opposite, more the hour you spend, less marks you score, covariance will be negative. Okay, something like that. So first thing that we need to do is construct the covariance matrix of this X across the features. Across the features means I want to construct, if this is X, I should construct covariance across the features, covariance between feature S and the feature M. Okay. So covariance can be defined something like this. So this is the expression. So you can see that points of X, how the X points are deviated. Likewise, Y elements are deviated. So this is the covariance. So you want to construct covariance matrix for all possible features. So now this covariance, constructing this covariance matrix can also be realized in this manner. So you have taken S and M features. So first thing in the covariance matrix, if you see the deviation of the points from the mean, right, for each features. So for each features, this is the mean adjusted. From the mean, how points are deviated. From the mean, how points are deviated for the M features, and you perform product of these two, and these are the and this is the average. So you perform sum of all these elements and divided by this number of elements. This average is going to be the covariance. So this is the covariance between feature M and S. Okay. So this you can easily see that. So if B is the mean adjusted matrix, that means from A is the original matrix, this one. Okay. Then you have B now. So B is like this is B. This column and this column. These two columns together is the B. So now if you perform dot product between these two, B transpose into B, you are going to get a covariance matrix A with a dimension 2 by 2. 2 rows and 2 columns. Can you see that? So if you perform B transpose and B, where B is nothing but this matrix, is I minus is mu and min and mi minus m min. So product of this, so this will be like you are going to get this is nothing but you are going to get say 2 by 2, where 2 is the number of features. So when you have the covariance matrix, you're going to have a square matrix of the dimension where say number of rows and number of columns are the features. If you say you are getting a covariance matrix of dimension k by k, it means you are getting a k number of features. You are having k number of features. So this is the covariance matrix. Okay. So now on this covariance matrix, you perform eigenvalue decomposition. So what I am having here is the eigenvalue decompositions on A. I am performing eigenvalue decomposition on A. Okay. So when I perform eigenvalue decomposition, what I have, I'm getting Q sigma and Q transpose, the same thing that I here, Q sigma Q transpose. After that, so now originally you have two. Now I want to reduce to one features. Then what I will do, I will from this sigma, I will only consider only say principal eigenvector. So if I want to reduce to k number of features, that means I have to only select k principal eigenvectors. That's it. So That is what the dimension reduction. So now I will have, so after removing this, this is my Q. Okay, this is the Q that I have. So now original Q was having 3 columns. Now if I remove the last eigenvector, so now I have reduced to dimension 2. Let us say this is Q. Right. So now how do I research? So now this Q is like a projection matrix or like a transformation matrix. So now if I want to reduce original features, then the original model, okay, the vector with the say k number original space, I have to multiply with this. So if you see here, so now this Q is the already, okay, this is already in the reduced space. So now original vector sample, when I multiply this X with this Q, what I will get? So this original is, suppose original is something like 1 cross, let us say originally you have something like 10 features, then this will be, and this Q is like 10 by 10 by, if you are reducing to 2 features, you will have this. So you are having original vector is like vector of 10 features, and a Q is like you have 10 number of rows and a 2 number of columns. If you perform this product, you are going to get this X prime, which is nothing but 2, 1 into 2, right? So this is how you're getting. So now you can reduce from 10 features to 2 features now. This is what the principal eigenvector. Okay, so in the in the principal component analysis, this is how we are going to do. So just to recap, first you have to take the create the covariance matrix and perform EBD on the covariance matrix, and select that many number of eigenvalues that you want to keep for features. Suppose from 1000 I want to reduce to feature 5, I will just keep the principal 5 eigenvalues and the corresponding eigenvectors. Okay. So this is principal eigenvectors. So in the very similar line, you also have some latent semantic indexing. Okay. So latent semantic indexing, for latent semantic indexing, we use something called, instead of eigenvalue decomposition, we use something called singular value decomposition. Okay. So what is the difference between singular value decomposition and eigenvalue decomposition? So in the eigenvalue decomposition, you are dealing with the square matrix. In the singular value decomposition, you are dealing with rectangular matrix. Suppose is rectangular matrix, not a square matrix, then I cannot apply eigenvalue decomposition. You have to apply singular value decomposition. So this pictorial representation explains that. Suppose this A is a rectangular matrix, right? So you cannot apply eigenvalue decomposition. So when rectangular matrix, instead of eigenvalues and eigenvector, you have values and singular vectors, left singular vector, right singular vector, and so on. Instead of eigenvectors, you have singular vectors and singular values. So that is the you please see what are singular values and singular vectors if you remember. Okay. So what is the decomposition here? Let us not worry about the mathematical technique details. So let us, but conceptually, let us try to understand what is this. So now A is the rectangular matrix. So this rectangular matrix, if I am using singular value decomposition, I am decomposing this into U and a B transpose, just like your eigenvalue decomposition. You have this U matrix, sigma matrix, and the B transpose matrix. Okay. So what is this U? So this U, so in this U matrix, the column vectors U are the eigenvectors of AA transpose. You have AA transpose here. So U, the column vector of U are the eigenvectors of A. Similarly, for V, column vectors of V are the A transpose A. Okay, and what is this? This is again a diagonal matrix. Okay, so here the dots are the vector of A transpose or A transpose A, because A transpose and the A transpose A will have same eigenvalues. Okay. So these are the eigenvalues of A transpose. So now you have the U, which is nothing but the eigen vectors of A transpose. You have V, where V are the eigenvectors of A transpose A. Okay, and these diagonal elements of this uh, diagonal matrix are the eigen A transpose or A transpose A. So this, in terms of singular value, and the eigenvalues are quite related. Okay, so singular values are eigenvectors, eigenvalues, and so on. So now, in other words, these columns, which is nothing but the eigenvectors of A transpose, this is known as the right vectors of the matrix A, and these columns are the left singular vectors or singular vectors of this matrix A, and these diagonal elements are known as the singular values. So, without understanding the theoretical implication, let us say in the singular value decomposition, you can decompose A into U matrix, sigma matrix, and the V matrix, and this is how it is decomposed. So the moment you decompose, how do you realize this representation? So you can see that the first row of A matrix, the first row can be represented by the first row of U. Okay. Second row of can be represented by the second row of U, and so on. So rows of A can be represented by the rows of U. In a similar manner, of A, first column can be represented by the first column of V transpose. Column can be represented by the second column of V transpose, and so on. So can be represented by this column vector. This column vector can be represented by this column vector, and so on. This is how I can realize from this decomposition. So this is what the singular value decomposition. Then what is LSI or LS indexing or latent semantic analysis? So here, so in the LSI, just this is like you are trying to reduce the dimension. Eigenvalue decomposition. Say, I will say that if I want to represent this row of A, which is 3, represent by 2, I want to transform these features to 2 features. What I will do is I will just consider the principal this singular values. The first largest eigenvalues, singular values I will consider. The first 2 dots I will consider, and the lower part I will ignore. So this is what this picture is trying to show. So this part, this white part, is something that you are ignoring. So when I ignore this part, so this U, instead of considering entire columns, I will reduce to this shaded columns only, this shaded part. Likewise, B also will be reduced to this shaded part. So now, likewise, every row of A, after shading it, that means after removing this lower part, the rows of A can be represented by the rows of U in the lower dimension. So initially, the dimension was N. Now, in this example, it is reduced to K, where K is much less than N. So this is what the LSI. So in LSI and principal component analysis, in both the cases, we are using factorization, and the whole idea is find the eigenvectors and take the projection of the original sample in the original feature space to the selected eigenvector space. If I say I'm selecting 2 eigenvectors, you are reducing to 2 dimensions. If you say I'm selecting 3 eigenvectors, then you are reducing to 3 eigenvectors. Depending on to what dimension you reduce, okay, that many number of eigenvector you will select and the transformation. Okay, that is for the LSI. Which should so these are the brief understanding of LSI and the PCA and the different feature selection methods. And with this, I will stop for this theoretical part, and this discussion we will see in the lab sessions. If you have any query, I will be happy to before we start the lab sessions. So now lab session will be taken by Gyanendra and Nilakshi. I would like to request Nilakshi and Gyanendra to put up your and I would like to request Naresh to change the presenter to Gyanendra. Let me stop sharing.
Thank you, sir.
So, okay, if you have any other questions, I'll just.
So that will be in our upcoming syllabus. For now, you go back and write the eco.
No, sir. Can you mute the
eco server for both?
Naresh, can you hand over the presenter option to Gyanendra?
Ranbir,
Sir.
Okay.
there was a question.
So
what is level of alpha in chi-square?
I have noted everyone.
Can you change the presenter to Gyanendra?
In the class, and if you are having troubles or you are disconnecting often, please.
Okay.
Send me,
the question, sir?
That is, what is level of alpha chi-square?
Please text me on
level of alpha in chi-square. I'm not able to understand what is this alpha.
That is what I want.
In chi-square, you have used any alpha, or I don't think so. But question is like that.
I'm not able to understand this question, but if you elaborate this, maybe I'll take up.
Okay, Gyanendra, continue.
Yes, sir. Hello, everyone. I'm Gyanendra, and I'm currently a PhD scholar in doing research on sentiment analysis under Dr. Shansan Ranbir Singh. Today, I'm going to present about the lab session 2 about feature selection. So yesterday we had discussed about building a classifier. So first of all, we need to define tasks that what we are going to do. So first, for this session, I'm going to talk about on the sentiment analysis dataset. So first, I load the text. Since I'm using Google Colab, so I need to take the authentication. So I have done that part beforehand. So I'll load the dataset. So that, so this is one example about the sentence that I have loaded. So in sentiment analysis, usually it's a the dataset that I have chosen is from the Twitter domain, and for a sentiment tweet is labeled as 0, which is negative, and 1 as the positive in the dataset that I have shared. So once the dataset has been loaded, we need to pre-process the dataset. So for pre-processing, what we have taken the steps are like removal of stop word and then removal of the URL links that is present in the tweet. So once we clean the dataset, so we capture the vocabulary present in the dataset. So I have stored the list of tokens in the vocabulary list. Then after capturing the vocabulary, we are going to convert this to the vector space. I think we had discussed this yesterday, so I'm just repeating. After the vector conversion, means I'm transforming the tweets to the vector space, taking as the feature the whole vocabulary present in the dataset after removal of the stop word. So the number of features that I have in the to represent it is 12,213, and the number of samples that I have is 11,043 samples. Means that 1,200 number of tweets. So coming back to the feature selection. Usually, why we are doing feature selection is because the number of sample features that we have considered is very large. So we want to reduce the number of features that we have chosen and select only the best feature that we think that this will be the best feature to represent the tweet. So for this, as I have discussed about mutual information and L1 best feature selection. So in this session, I'll discuss about how we are to explore this, use this mutual information best feature selection from the toolkit scikit-learn. So for this, you need to import this sklearn from sklearn.feature selection. You need to import this mutual information info.classification. So this toolkit will take some time because you need to calculate the mutual information for all features that you have provided, 12,000 features. This function, if you expand, first they will calculate the mutual information for each feature according to the label provided, that is y level. So for each feature, you will calculate the since I have two element in one sample in y level. So that means positive and negative. So I'll calculate the mutual information of a token, like suppose a word, suppose any word that selection is calculated for mutual information for positive as well as negative. And then we'll select the best mutual best means the higher one among the two, that's positive or negative. If you have any question, I'll take up here because it will take some time. Hello?
No question till now.
Sorry. Yeah. So we have calculated now the mutual information calculation for whole token has been completed. So let's see the features. So for the particular word, means feature number one, which is For the word vocabulary Excel, the PMI score is machine information score is 0.01195. So I'm going this particular PMI score. We have to take. I'm taking the average PMI score to select the vocabulary which is above the average PMI of the whole number of tokens that I have in the corpus. So for this, I'm taking the average, and then whichever Muslim information that is greater than the average, I'm selecting this as a feature. So total feature that I have selected for this PMI base is 4,297 number of tokens that I have selected for as a feature. So this can be improved based on the condition you want to take. It can be average. It can be number of you have specific number of PMI score. Then I have selected after the Muslim information calculation. So once the feature has been selected, I need to convert this to the vector space for its tokens, for its tweet samples. So tokens X is the number of samples that I have pre-processed for each tweet. In this vector feed, I have appended the vectors representation of each tweet. Then I convert this to the matrix format so that the machine learning toolkit can use this particular variable. So for this, I need to import this classifier. I'm using for this session. I'm using the SVM classifier, but we can use decision tree, KNX, never, and many more that we have discussed yesterday. So I have loaded the SVM instead using linear SVC, and then I have fit the vector representation that we have converted just now with the level Y. Since it is completed now, so let's predict the particular this example. Where is it? So this is one sample example. I love watching Netflix movie. So it is converted to the vector representation using the feature that we have selected. And then this is the picture of this particular word, Netflix. So this is predicted as positive. One represents the positive sentiment. Another is the negative sentiment, which is I had watching Netflix original movie. So I've converted to the vector representation. So let's see the sentiment of this particular sentence after feature selection. It comes as a positive, positive, but means so we need to tune the number of features here. So how we want to select? Since I have selected as the average, and the calculation is based on the PMI score. So it depends on the number of features that you have selected. So we need to tune the features. So for this example, we have for both the tweet sentiment for both the tweets, it is produced as positive sentiment, which is wrong for the negative one. So another one is L-based feature selection. So this is the third category that I have discussed. So in this case, we use the L1 lasso one penalty for selecting the features. So it can be done using either SVM or logistic regression. So for this case, I'm using the SVM. So we fit the vector along with the level, and then we choose penalty as 0.01. So this is the parameter. If you want to select higher number of features, then we can change this to higher number, like more greater than some number, like let's say 5. So when I choose 0.01, it was 7. So if we change the C parameter, it will select higher number. So L1, but basically L1 does the shrinking the coefficient of a feature. So coefficient is the score of the feature. So if you get minimum score, minimum parameter, it will shrink to 0. So those features that are greater than 0 are selected. So if you keep minimum parameter, it will select less feature. If you keep means higher parameter, it will select larger feature. So once the feature selection has been done, so I put new vector representation to the classifier. So similarly, let's take for the same example. Let's see how it is predicted. So the particular sentiment, I love watching Netflix, is predicted as positive sentiment, and for it, let's see. Again here, so it was initially predicted as 0, but again, when I do again repeatedly, it brings to positive again. So we need to tune the parameter select for this feature selection. So up to now, we are doing this only on the feature selection. Means we are neglecting some of the features that are not important to us, and selecting the features that are important based on the score. So this might miss the some of the important features that might be distinct for the classification, but based on the feature selection score, it is neglected. So we don't want to miss this neglect this type of feature selection. So instead of that, given the matrix, the whole vector, I want to decompose it to lower dimension, which is the equal representation, somehow appropriate representation of the large vector. So PCA is the I can value decomposition based dimension reduction. So in PCA, so in scikit-learn, you need to import this sklearn.decomposition import PCA. Create the instances PCA and number of component. I have set to 200, but it can be your choice. So after that, you transform this vector using the PCA transformation, and then this is the representation. X new is the representation of the input vector. So 200 is the 11. The 100 cross 200 is the equal representation of the vector 11 cross 12,000 attributes that we have discussed above. So we now fit this to the SVM classifier. So I turn very fast. So let's see about this particular tweet sentiment. I love Netflix. So for this, since we need to transform this tweet to vector space, first we transform this to the actual vocabulary that we have used feature. And then using the PCA transform instances, we input this to the vector representation of this particular tweet. And then this is the decomposed representation of the back post. Now let's see the sentiment of this particular queue. It comes as positive. Let's see for I had -1. Yeah, it comes as negative. So here we show that the representation, the whole vocabularies that chosen in the features are being captured. But in feature selection, we could miss the important features that we want to select for representing discriminating the classifier. Let's move to the second part, means SVT decomposition using LSI method. So for this one also in the scikit-learn, we have sklearn decomposition import truncate SVT. So here we have number of components I have chosen equally, and number of iteration is based on the and these are the parameter that you want to perform, which is I have set at the default parameter, which you can change this parameter. And then similarly for SVD also, you need to create the instance and then fit the vector. So I have fit to 200 dimension and then run it to the SVM classifier. So let's see for SVD also, the positive sentiment. Okay, it comes as positive. For positive, I love Netflix, and for negative, let's see, it comes as negative. So here I end my demo, but this particular notebook I have shared in the GitHub that we have shared in the previous link that I have shared yesterday. So you can collect take this code from the GitHub. Is there any question that I can present?
Any questions? So that he can elaborate that part. Till now, no question.
One question.
Which one?
Miss, to share the code. I have shared the code in the GitHub. I'll provide you the link. Just give me a second. So this is the link that you can collect the particular today's demo. The file name is feature selection. I think there is no question.
No, there is no questions. You can elaborate something else. It's fine. Or you can prepare
So
for tomorrow's things. Nilakshi is there also. Okay, can you explain little slowly then if someone missed it?
Yes, sir.
Oh.
I'll explain from the this one, the stopwatch mobile part, so that this function might
Once
be
more
clear.
you repeat. Once more you repeat from the first.
Yes, sir. Yes, sir. So for building this paper, first we need to define the domain that we want to do or the task that we want to do. So it can be sentiment classification, it can be language classification, or any classification task. So for this session, I'm using sentiment classification, but we can use language classification also. I have shared the dataset, and then like this one, spam detection. So using this sentiment classification dataset, I have from the machine learning tasks. This the representation of the sentiment and the label in the particular dataset is like this one. It is step separated, and by first column is the first column is the width, and the second column is the level. Okay, and then after this selection of data set, we need to prune the tokens that are less important, that we feel that it is less important. So I have chosen the stop word as the less important for classification, means as a feature for classification. So first we clean the input text, like removal of URL or and removal of stop word. So and if you and for this stop word also there are many stop words. So I have not removed the negation part, only the basic stop words. And then I had capture means collect all the vocabularies present in the dataset as the feature. So after capturing this as a features, I took this as the attribute for representing the width to the vector space. And then after converting the whole width samples to the vector space, I can transform this to the matrix format, SQL matrix format, so that the machine learning toolkit can use this in this format, NumPy as array. So this particular dataset has 12,000 number of features, which is very large. So we want to reduce the number of features and select only the best performing feature. So for this, there are two types of feature selection that I have used. One is mutual information based and another is L1 based. So in mutual information based, you first find the mutual information for whole vocabulary, that is 12,000 tokens, across the level, sentiment level. So in this particular toolkit, you don't need to implement the step like calculating the mutual information for positive sentiment and negative sentiment, and then finding the greater one, and then selecting the score of the token. This particular mutual info class classification function will perform these three major tasks that you need to perform individually. So this particular function return the mutual PMI score of each token. So for example, this particular Excel, which is book one, which is feature one, it has this PMI score 0.01195 PMI score. So I need to select some threshold. I need to set some threshold. What is the threshold that I have set? Is the average from this whole PMI score of the vocabulary. So this can be changed according to the wish that you want, like median or like the particular standard point that you want to decide based on the example. So for this session, I have just took the average as a threshold for selecting the feature. So after setting the threshold to average, I have selected number of features as 4,297, and these are the number of features that I have selected. So this feature is automatic selection, so it may have the feature that we don't want, and it might have missed the features that we want. So that need to be captured in the dimension rejection. So after feature selection, we need to transform this to a vector space. So after this transformation, we similarly we convert it to the matrix format so that the classifier fit. So for this particular task, we have used SV classifier and fit the classifier with this reduced feature selected reduce dimension using the feature selection and then the label. So for the positive classifier, for the positive tweet that I have chosen as example, it was classified as correctly, but for a negative, it was classified as positive, which is wrong. And then for L1 best feature selection, here also, this is like type of another type of feature selection where it is based on the classifier based feature selection. So we set the penalty for classifier as L1, which is less so. And then the parameter for shrinking the coefficient of the feature score is I have set to 0.51. But if you set to lower parameter, it will select the minimum number of features, and if you set the higher, it will select larger number of features. So 0.5 while selecting 0.5, I have selected 2716 as the number of features. So after reducing this to the dimension 2700 features, we have trained to the SVM classifier, and for positive sentiment tweet, it was classified as I love Netflix was classified as positive, and for I hate Netflix it was classified as positive. So here we observe that the feature selection has missed some of the important features that can capture the sentiment. So in dimension reduction, instead of neglecting the features, we are transforming the whole features matrix to the lower dimension. For this, we have used PCA, which is eigenvector-based decomposition. So in this particular task, we just import the PCA from sklearn and then create the instances of PCA, and with the number of components 200. This is the dimension that we want to transform, which means the number of eigenvector that we want to choose. So I have choose 200 number of eigenvalue. And then we fit the vector, and then the shape of this I have fit this to the SVM classifier. So let's see for positive tweet, there is I love Netflix. It was classified as positive, and for I hate Netflix, it was classified as negative. So this was the positive feature itself helped in classifying. It means the reduction in capturing the features importance. And in SVT, similar to the PCA, it also uses the decomposition, number of component 200, and then after transformation, it is being fit to SVM classifier. And another one thing, so when you convert this particular tweet to vector space, you have to convert to the actual size that you have used. So I have used the whole vocabulary as a feature. So the transformation of the tweet to vector is of the whole vocabulary size. So you have to transform by passing to the SVD instance. This particular tweet, I love Netflix, it was classified as positive, and I hate Netflix was classified as negative. So this is the task that we had done.
Anybody has any questions or any clarifications? Please. Okay.
So I have some question, 2-3 questions. In multi-class text classification, sometimes we get the feature that is belong to more than 2 classes. How to resolve this issue? So, Miss, here, as we have discussed in PMI, the entropy based feature selection. So, if this particular feature belongs to more than 2 classes, the entropy will be higher than the feature that belongs to only 1 class. So it is better to choose the lower one, the lower entropy. So so for this type of features, the PMI score will be less, and the for features with only one belong to one class will have higher PMI score. So we will select the higher PMI score. Which technique is best suited for dimensionality reduction in text classification? As of now, up to now that we have explored, and SPD and PCA is equally performing, but coming to the deep learning part that we will discuss tomorrow. So deep learning based technique will usually perform better than the SPD transformation or PCA transformation. Another question: how we can use optimization technique like GSA or PSO for feature selection? I don't know what GSA is.
No, these are not related to machine learning. This is related to the evolutionary techniques. So obviously that system is totally different from this. So it obviously will perform, but we cannot say at this moment. The new question you have got it? You got a new question.
Yeah, so this one also other. So here PCA we usually do statistical based PCA transformation, but in neural network, it tries to capture the latent information from the data itself. This autoencoder will means input will try to recreate the input as the output. So the result will be the yes, sir.
This question should be answered tomorrow, because tomorrow and day after tomorrow we'll talk about autoencoder, correct?
Yes, sir. Okay, sir.
This question is
Yeah.
going towards that. So basically, when we'll discuss the deep learning technique autoencoder, that time we'll answer this question, correct?
Sure.
Okay, this question remain. Tomorrow you can answer. No problem. So,
thank you, sir.
What? Any other questions? Private or public? Any other questions?
No more, sir.
Okay. So, what is tomorrow's lab? How they prepare Ganendra and Nilakshi? Tomorrow, if they have to prepare anything,
going to present.
So what are the should do or do not, or prepare and come? Nilakshi, you have anything to say?
So tomorrow we are basically covering the basics of neural networks. Like we'll talk a little bit about how to build some basic neural networks like a multi-layer perceptron, and we are also planning to discuss a little bit about about generating word embeddings, how we can use those generated word embeddings as features. Now today we have seen that we have defined set of features and we do dimensionality reduction over that. So instead of explicitly defining features, how can we generate some inherent features, and how we can use them as features for in traditional neural networks, or sorry, in traditional machine learning frameworks as well as in neural network frameworks. So if so whoever is interested, if they explore a little bit about word embeddings, like how word embeddings are generated, and a little bit about the basics of neural networks, then it will be helpful to carry on the session swiftly. So we are not going to very high level details tomorrow. We will limit ourselves to basics for tomorrow.
Okay, so same environment we will continue, correct?
Sorry, sir?
Or environment will be same or different? Or toolkit and other things?
So yeah, if possible, people can come installed with deep learning libraries like Keras. Maybe all machines may not support installing them. So I think people can also try to use Google Colab. So Google gives some free listing for using these tools and libraries. So if it's possible, people can install the Keras library in their machine. I think that has already been given to them, like what are the tools required to be installed.
Correct,
And
correct.
and also cannot install in their system, so you can try using Google Colab.
Okay. Okay. So today we reach to end. Tomorrow we'll see morning session. There will be one talk and one important thing. So related to several questions as asked, that how to collect data from different social media analytics, then how to do Spark framework to store, and how to do process, how to evolve all these things. All we'll talk at the morning sessions with social stress detection and social media data, and this, and also what software we have developed. That software developed also will give a glimpse what we have done. So we will have these two. Please do not miss, because you will get how to collect data, how to store data, how to process data, and how to manage those data and evolve something along with that talk in the morning session. So we'll meet tomorrow morning at 9:50. So 10 we will start. Thank you everyone. Thank you Ganendra, Litsi, and everyone, all participants. We'll meet tomorrow. Thank you.
Yeah, thank you, everyone.
Thank you, sir.
Naresh, we are closing.
Thank you, sir. Thank you very much, sir.
Okay.